I don't want to be a product of my environment. I want my environment to be a product of me.
Pure magic, Penny with the step back, rocket that shoot from the rear, Kenny jetpack, AR long clip and it's jet black. When it got the big guns, have you met Shaq? Landing face first with 30 in his jersey. I don't see Curry, but it still look like step back. Burning bridges down to the court could be a setback. Rather play the game with Claymore, Death Trap. Joining Linky, Chris Bosh if it's bout beat. Raise this rap and get the clapping niggas out seats. Come and fellowship with this clip. This an outreach, turn a 23 cab to a 6. If you doubt me, bow please. Before I take my talents down to South Beach. Big 3, this D-Wade all about heat. Need coach, Pat Riley with East Coast. Key 40, I ride with Hassan, that's heat culture. While I try to understand why they mad at me, cause I tell it how it is, not how it has to be. The elders think you a joke, they hate you have to speak. All I see is sacrificial goats and casualties. I found waiting Jew by the throat and drowned him casually until I felt him give up the ghost and lost his faculties. Thought he had a team, but it ain't a soul that can match with me. I'm trying to imagine who he got in back of him. Smacking Davion with a metal back till he crack his spleen. Don't need lesion, you ever thinking combating me. Demons start to squeezing through the cracks in my anatomy. Desolation, abomination, making bacon off the back of him. They keep squilling, but they never let that action speak. The high priest keep flame, about to have a feast. I never led the pig to the slaughter. You know I had to see, I'm about to put that pig on the altar. First Maccabee, now that's a Torah night, temple man catastrophe. And I'm shipping off every brick I find attached to it. Got him passing me gasoline, I set a match to it. Claim to be an Israelite, all his teachings is half Jewish. We watch the niggas sell his soul and then gon' half do it. Like the devil ain't collected what you passed due. Humiliation rituals, that's what they had to. We just set up the fire just to watch you pass through.
I'm finna take a trip to Japan, we gon' need the chopstick. I got poles on the low, case we need the mop shit. Knock his noodles out the bowl since he's speaking hot shit. I can get it any dough, I don't need a locksmith. You gon' make me turn your lion's den into a lion's pen. Jumped up out the fire, landed in the frying pan. So that I'm Daniel in the lion's den. And if he even show his teeth, then I leave looking like a lion's fan. I'm tryna leave unseen with the shooter pack. They got me out here maneuvering with sewer rats. I'm tryna lead Judah brains all in Judah lap. That's aside from Judah Nazareth to Judah Knack. Then a return to the scene, I'm just cruising back. I'm just a killer, so I figured I'd do a lot. Like the whole HOK got Judah back. First I never found this lid and try to screw it back, but couldn't salvage no remains, so we throw this it back. This is where we move them back. We gon' draw a line in this section. Know I'm connected, but never name my connection. Ain't a question, it's the closest you get into a confession. Take a trip to Japan, we gon' need the chopstick. I got poles on the low, case we need the mop shit. Knock his noodles out the bowl since he's speaking hot shit. I can get it any dough, I don't need a locksmith. You gon' maybe turn your lion's den into a lion's pen. Jumped up out the fire, landed in the frying pan. So that I'm Daniel in the lion's den. And if he even show his teeth, then I leave looking like a lion's fan. The only type of nigga I know that to the most lies. When he put it on his kids, his soul to the most high. He looked you dead in your face, in both eyes. If something happened to them babies, then you know why. I see polite set a standard that you hold high. I had the bar so low, couldn't go by. Draw a line on you niggas playing both sides. I'm in the face of JJ 7K with a 4-5. Got me out of picking strays, ain't it funny, cat? Why they call them lions then? I used to wonder that. Until I seen them get on Sonetta and do a thunderclap. Hear him say he lying, I'm putting cage on the Thundercat. Dare you to make me get the tape and have to run it back. Watch him play like he immune to the fact. He just left Sonetta, but he soon to be back. Lions didn't get around, that's community cat. Lone wolf, but I ain't moving in pack. I hit Japan, you can feel it in your shoes like I'm moving the map. He getting nailed to the cross, we keeping Judah intact. This flood of tsunami is moving them back. This kick in the body lets you bring in a fight. These niggas is on the spectrum, they ain't bringing no light. It's such a saying they claim the fame is off the name of polite. Flip a switch, don't they all look the same in the light? Pop my shit, I'm just putting the team on. Trying to see how much love they got to give when the steam gone. Wouldn't be blue if I ain't give it a theme song. Just look around, I ain't been on the scene long. When the last time you think Judah done been home? No time soon, cause that nigga been gone. He put the crown on the pie and to me it just seemed wrong. Take a knee, or get a bow at Queens. And then take a trip to Japan, we gon' need the chopstick. I got poles on the low, case we need the mop shit. Knock his noodles out the bowl since he's speaking hot shit. I can get it any dough, I don't need a locksmith. You gon' maybe turn your lion's den into a lion's pen. Jumped up out the fire, landed in the frying pan. So that I'm Daniel in the lion's den. And if he even show his teeth, then I leave looking like a lion's fan. I told y'all it wasn't go in with him. Yeah, they gotta put out an APB to find you. I already told y'all where JJ gonna be at. Right back on side net of lap. Quit playing with you and them little kids. Y'all mentioned the name of my chat. I'm straight, bro. We got him. What you said, hood therapy? I'm finna take a trip to Japan. We gon' need the chopstick. We gon' need the chopstick. We gon' need the chopstick. Oh, you want it? Solar mine?
Power to the My fault. Power to the dark side. Power to the dark side. Was good with the family. You already know we got to give a special praise to the most beautiful goddess of science. Hold up, actually, let me make sure my goddamn audio is working. Cause that seemed to always be some shit. Let me see. Yup. Make sure that's good. But yeah, power to the dark side. Y'all know we gotta give a special praise to the most beautiful goddess of science, technology, engineering, and mathematics. STEMia, whose image is the most beautiful Whoopi Goldberg. Shout out to all my Babel builders in the building. Remember, if you are listening to this together, we are Babel. Let's build. So today we got another one, right? So we finna tap in to a debate on whether or not we live in a computer simulation, right? And so basically, this debate is we gonna get a chance to listen to what will, and I say this loosely, expert scientists, right? We get a chance though to listen to them actually define reality as we know it, right? And because this is basically what we're talking about, reality, and whether things in reality and nature always fits the laws of what we call physics, right? So we're gonna get a chance to kind of tap into that. So without any further ado, like I said, I was actually gonna watch this on my own. I wanted to listen in, but I was like, fuck it, I'll do it with a live stream. So I kind of held out to be able to get a second to do this with y'all. So let's get it in. But like I said, yeah, this gonna be you gonna get to hear from Neil deGrasse Tyson, Isaac Asimov. It should be a pretty good discussion. But this is from the American Museum of Natural History, right? From the American Museum of Natural History. All right, let me go ahead and hit this thumbs up. Go ahead and press play. Oh shit, I gotta break it in.
And we've been going strong ever since the year 2000, when an idea surfaced in the hearts and minds of the family of Isaac Asimov, exploring a way for his memory to be preserved in the programs of this institution. And Isaac Asimov.
Now, as we watch this, I want y'all to pay close attention to when you hear how Neil deGrasse Tyson the type of attitude or energy that he sort of suggests towards even the idea of us living in a computer simulation. And then I want to see how his energy is as we get to explaining what reality is, because that's going to be very interesting. Because remember, the stance here is that reality is an agreed upon illusion. Remember that. That's already our premise. So we just want to see is as their discussion unfolds whether or not they fit our premise.
I was a friend of the American Museum of Natural History. Much of the research for so many of the books that he wrote took place in and around the halls and in our libraries. And so perhaps there's no more fitting tribute to him and to his memory than to keep this celebration going. So thank you for attending. We are also streaming live on the internet, and I'm your host for this evening, Neil deGrasse Tyson. I'm the Frederick P. Rose Director of the Hayden Planetarium. There's a couple of newsy notes. This year, we sold out in 3 minutes, and it's not a particularly sustainable model. So we're gonna have top people looking at how to sort of improve that next year. We don't know how yet, but the least we can do is offer it live streamed on the internet on amnh.org. So I welcome everyone from the internet universe as well as the universe gathered here. Tonight's topic is the universe a computer simulation? Yeah.
You'll see how disrespectful that is.
I mean, this topic is we're gonna, it's
very, very possible. And matter of fact,
we've got some
more than likely
thoughtful, talented, respected people to.
Like, this is crazy. I just want y'all to really pay attention to his attitude towards it. And what you're gonna really find out is it's actually very likely that's exactly what we're in. We'll continue though.
Weigh in on this. I will introduce them individually, and then we will start the panel. By the way, unlike most debates you might have heard about or read about, where there's point, counterpoint, and an argument is presented and attacked, that's not what's going to happen here. We're using the word debate loosely. Think of yourself as eavesdropping on scientists at a breakout room in a conference on this topic. So we'll all be sort of arguing with one another, and you're listening in. That's really what's going on here. And you get to see how scientists think. You get to see how arguments are contested. You get to see how resolution arrives, if it arrives at all. So afterwards, we will have a brief time for question and answer before we adjourn before 9 o'clock Eastern time zone, Eastern Daylight Time. So join me in welcoming my first panelist this evening. He is a professor of philosophy at
Facts, Astro.
He's also director
Peace.
Center for Mind, Brain, and Consciousness, David Chalmers. David, come on out.
Hey, looking forward to this.
Thank you. Next, we have a nuclear physicist who is a postdoctoral research associate at MIT up in Cambridge, Massachusetts. And let's give a warm welcome to Zohore Davoudi. Zohore. Next, we have someone who's actually no stranger to this panel. This may be his third visit to it. In part, the topic of this year was selected because he brought it up like a couple of years ago. And I said, man, we could do a whole subject on that alone. Let's give a warm welcome back to James Sylvester Gates. Another non-first-timer is a professor of physics up at Harvard, a specialist in nuclear particle physics. Give a warm New York welcome to one of our own, a graduate of Stuyvesant High School, Lisa Randall. There's a friend and colleague, an astrophysicist, also from MIT, who's done some deep thinking about this very subject and has even written a book on the topic. Let's give a warm New York welcome to Max Tegmark. Max. By the way, we are sort of lit for live streaming, and the intensity of the lights on this stage is such that two of our panelists, I think they just want to look cool, but they said they need to wear sunglasses for this event, and that's cool. Later on, I might join you. I brought my pair with me as well. If I'm feeling cool, I might do just that. Zari, I'd like to start with you. No, who should I start with here? Yes, let me start with you, Zari. Can you tell me why this topic interests you? Just give a couple of minutes just as introduction here.
Sure. So, as Neil said, I'm a theoretical physicist. My interest is in nuclear physics. In fact, I got my PhD in 2014 from Institute of Nuclear Theory in University of Washington. And the research I was focused on there and at the moment is trying to use the knowledge of the laws of nature, and in particular strong interactions, to start from a bottom-up approach and try to see what comes out in a physical system. And that's actually relevant to why I got interested in the simulation idea. And in fact, by just watching the progress that researchers in this field of simulating strong interactions have made in the several past few years, we started to wonder how could we not think about the universe itself based on the laws that we've discovered, not simulated. So the way that we actually simulate the universe, it might actually give us hints that the universe itself could be a numerical simulations. And then you would start thinking, well, let's make assumption that if that scenario is the case, and if that simulation is actually has similarities with what we do in our research, and just drawing parallels between our algorithms and techniques that we use to simulate laws of nature, and making assumption that they are similar, then what can we actually conclude about the universe as a simulation? Can we actually make predictions for the signatures that we should go after and test? So that's the approach we took, and it was a fun idea and fun paper we came up with my collaborators, Martin Savage and Silas Bean at the University of Washington. And that's basically why I'm here. I'm trying
So the prospect of this being true didn't freak you out at all?
No, I think it's a fun idea.
Okay, it's fun for you. Okay, fine. So Max, you've got a book on this too, right? What's going on with you?
He's TMKC.
As a kid, I was always very fascinated by these very big questions about what was really going on with this reality. I remember actually lying in this hammock I had put up between two apple trees back in Stockholm, Sweden, when I was 13, reading Isaac Asimov. Actually, I'm very honored to get to be here. Where it really makes you think about these big questions. And the more I learned about later on as a physicist, the more struck I was that when you get deep down under the hood about how nature works, down to looking at all of you as just as a bunch of quarks and electrons.
Thanks.
And you too, it's not just us. Yeah.
Yeah.
Looking at you as a quark, no, you would come under this category as well.
I am a quark blob too, I confess. So, but if you look at how these quarks move around, the rules are entirely mathematical as far as we can say, Talon. And that makes me wonder, if I were a character in a computer game who started asking the same kind of big questions about my game world, I would also discover eventually that the rules seemed completely rigid and mathematical. I would just be discovering the computer program in which it was written. So that kind of begs the question, how can I be sure that this mathematical reality isn't actually some kind of game or simulation?
So you've analogized yourself to Super Mario in a is this who you are?
I don't know if that's a good thing or a bad thing.
So Jim, I just remember you started all this a few years ago, in my mind at least.
Yeah, I'm excited as fuck with this, Astro.
The idea that in your research, you found things that forced you to consider the likelihood that somebody programmed us. Could you?
Well, first of all, I would disagree with you. I'm not sure that somebody programmed us, but that's what you and I had a conversation where I pointed out that in my research, I had found this very strange thing. Physicists, I like to say we all belong to a company called Equations Are Us, because that's how we make our living, is by solving equations. And so I was just going through solving equations, and I was then driven to things that Max knows about, these things called error correcting codes. Error correcting codes are what make browsers work. So why were they in the equations that I was studying about quarks and leptons and supersymmetry? And that's what brought me to this very stark realization that I could no longer say that people like Max were crazy.
And real quick, I just want to take down the banner. All right, so y'all can see. I want to take down the banner so y'all can see who this brother is. All right, boom. Just so y'all can see exactly who we looking at. Y'all see who that is? All right, that's who y'all listening to. Just want to give y'all a little note.
Or stated another way, if you study physics long enough, you too can become crazy.
That's another. It's a corollary to that idea. Yeah.
And I'm also a science fiction fan. Like Max talked about his encounter with Asimov. I was reading at age 8 as opposed to 13, sir.
Snapped.
Go off the slow start.
I was reading at age 8 a science fiction book by an author named Paul French. And some people in the audience might know that's a pseudonym for Isaac Asimov.
Oh.
So science fiction drove me into science in some sense. And then now in my 65th year of life, I find out I have to make friends with Max and people like that.
So Lisa, I kind of brought you on the panel because I knew you. I mean, you're a rationalist in all this, and so I don't know what to expect. I just needed to anchor this in somebody who I knew was not going there. So
Yeah. So I actually, well, I can't say I decided to be on the panel because I think I said, "What date is it?" And they were like, "Thank you for agreeing to be on the panel." But I have to say, I'm curious not so much about the question of whether we're a simulation, because I think it's only interesting insofar as there are ways to test it. And we can come back to that, I think, very much in terms of sort of how the laws of physics operate and whether we can actually distinguish that. But I actually am very interested in why so many people think it's an interesting question. Like, why is the audience here? Why is this because really, to first approximation, we can't really distinguish it. So I think the interesting question is, why do we feel compelled to want this to be true or even think this could be true? And how do the laws of physics operate? And are there really ways that we could eventually test whether there is something that distinguishes just a true universe? But I should say, like, if the universe is a simulation, I don't understand why it gave me a cold today.
Okay.
And so my voice might go. But I also think sometimes, like, some of the ridiculous things in the universe, and think why would that be part of the simulation? And I realized if I was doing a simulation, I would definitely put those things in. So there you go.
Okay. Well, thank you for that. Now, we couldn't have a panel without a philosopher, David. We needed some philosophical.
I know how you love philosophers, Neil.
I'm on record for some comments about philosophers that got him a little ticked off. But anyhow, so David, what do you, philosophers have been at this for a while, yourself included. So how do you see all of this happening or fitting in to the worldview?
Well, philosophers like to ask the big questions about the world, the foundational questions, and this is one of them, you know. Actually, I blame Isaac Asimov for all this, at least in my case. I got into thinking about these big questions. When I was a kid, I read just about everything that Asimov was writing, not just the science fiction, but the science fact, the history, the detective novels. I read the multiple volumes of his autobiography, but throughout Asimov's work, this was a guy that was just interested in the big questions about the nature of reality at all levels. And that ultimately drove me to think about questions about consciousness and the mind, which I could approach as a philosopher, because philosophy allows you to kind of step back and say, what is the science here telling us? But this question about the simulation corresponds to another of the great questions of philosophy, which is basically, how do we know anything about the external world at all? And René Descartes said, how do you know you're not being fooled by an evil genius into having an impression?
So remember that whenever you're talking about philosophy, all we are discussing is what is the science actually telling us. That's all we're talking about. What is the science actually telling us? So don't allow people to be afraid to have that discussion, or have you afraid to have the discussion of exactly what it is that we are getting from the science. Because a lot of people, they tend to be on the edge when it comes down to that part of the discussion, and they try to leave it like, oh, they try to just downplay philosophy. But philosophy plays a big part in how we understand the science that we are looking at, the data
Of this world around us, even though none of it really exists. Well, the contemporary version of that question is, how do you know you're not in a simulation like the Matrix, in which case, allegedly, none of this really exists? And to me, that question is just extremely interesting, because it seems nothing we could know could rule out the hypothesis that we're in a simulation. But you also want to think about what follows. Some people think if we're in a simulation, then none of this is real. I think if you adopt the kind of perspective which, say, Max was suggesting a second ago, where the universe is all mathematical or informational, this allows us to reorient our attitude to this question, saying, okay, maybe we're in a simulation, but if we are, all this is perfectly real, because all the information is there in the simulation, all the math is there, all the structure is there in the simulation. So I'd say, well, maybe we're in a simulation, maybe we're not. But if we are, hey, it's not so bad.
If I do this, you feel that.
Yeah.
Yeah. Okay. So that's real. That was a real punch. Yeah. So Jorge, let me ask you. I see you coming to this almost from the most pragmatic side. You've done experiments with your colleagues, or you've had hypotheses with your colleagues. Could you just detail for me where you landed in one of those papers that you guys published?
Sure. So what we did is not actually doing the experiment. We proposed that experiments could go and look for the signs of a possible underlying simulation for the universe. And the reason we thought about this, as I said, is because we've been simulating strong interactions, which means that instead of just looking at the larger structures, we start from the underlying degrees of freedom of our theory, the quark gluons that we understand, and there are very simple laws governing the interactions among these particles. However, when you think about all these complex systems of atomic nuclei and larger systems in the universe, the ordinary matter in our universe, it all emerges from those simple fundamental building blocks and these interactions. So we've been trying to just input those simple mathematical structure with a few degrees of freedom, these quarks and gluons, and then see how these, for example, atomic nuclei emerge from these simulations.
So you're building the universe from the ground up.
Exactly. So, but what are the limitations? We don't have infinite computational resources. We have very large supercomputers in the national labs, for example, that we can compute these interactions, basically, and build up these systems. However, we are still limited. And the reason is that if you're interested in simulating the universe, and that's, you don't know what the size is, it could be finite or infinite. However, we are limited to a finite size. On the other hand, if you think about even a finite size, there are infinite numbers of points on these in this finite size that you have to simulate to get the physics right. However, we are not capable of inputting infinite number of information in our computers. Also, we want the simulations to be quantum, which means that there is not just one single path of evolution from one point to the other. There are infinite number of paths. Some are more important than the others. And therefore, there's another type of infinities that we have to implement in our simulations to get the answer right.
Yeah, but just because we can't do it because we're limited, why should that mean the whole universe is limited?
So wait, so this is the point. So
I got time.
All right, so we can't do it, right? And then based on the assumption that if there is an underlying simulation for the universe that has this problem, that has the problem of finite computational resources, just as we do, then what happens? Then the laws of nature, the quantum mechanics, and whatever interactions that are going on has to be put on a finite set of space-time points in a finite volume, and then just a finite number of quantum mechanical paths to a process can be evaluated. So these are the assumptions. So if the simulator of the universe in whatever form it is, has just finite computational resource and not infinite, then is limited to simulate the universe in this kind of limited scenario, just as we do. And then by making that assumption and then going back and look at our simulation and see what kind of signatures we see in the observables we calculate, that could tell us that we started from a non-continuum space-time, then apply it to an underlying simulation of the universe and make the same assumption, then what would you see? And that's basically what we look for, and list a few observables in our universe that might lead to actually constrain this scenario under this assumption. And one of which is looking at the spectrum of cosmic rays, because what happens if these very high energy cosmic rays that approach the Earth, they are actually traveling in a discrete space-time as opposed to a continuum, then their equations, basically special relativity that would describe the relation between the energy and momentum of this particle is modified. And then you would ask that, what would that modification mean in terms of the observation we make in our observatories for example, spectrum and then distribution of these cosmic rays. And if we see something that would be consistent with
Peace, Candy Cane. What's good? What you says?
Resources of the universe, and then you might think about other signatures and maybe taking this scenario more seriously and think about extending it.
So cosmic rays, it would be your pathway to the limits of what has ever been measured.
Exactly.
And then seeing if at that limit, you are probing the limits of the programmer of the universe.
Because these cosmic rays are the most energetic particles that we've ever been able to observe. We can't even produce them in laboratories. These are very high energy cosmic rays.
Very higher than anything we produced in our particle accelerator.
Exactly.
Yeah.
Yes, by orders of magnitude. Mm-hmm. And therefore, because these are very energetic, they can actually probe the fabric of a space-time. This is our way of probing if the underlying space-time is discretized or just a continuum. So
Max, you've written, like I said, you've written a book on this, yet you told me offline that you have an.
So y'all may not be able to, but what she's saying is basically, if they can observe these different types of energy spectrums, the ones that they can't recreate, and what they see is that they're actually bending space-time, so they're on a continuum as opposed to being trapped in the laws of physics, then what they able to do, yeah, this is one based off of whether or not we live in a computer simulation. And so that's what she's saying that they doing with in with what she does. I think she was a theoretical physicist, if I'm not mistaken. I think that was her. But yeah, basically they could test, whoever it is that they trying to see if they could test the laws of whoever created the simulation or whatever created the simulation, and that exposes a lot.
Argument that would argue that
maybe we're not simulated after all.
maybe we're not a simulation after all. So where does that land?
Yeah, so before giving a counter argument, we give the pro argument. So of course,
so you can give arguments in both directions here.
It's fun to argue with yourself. Okay. So of course we all, as David mentioned, have seen the argument, the idea of us being simulated in the Matrix and in science fiction going even far beyond that. But the guy who really started forcing scientists to take this a bit more seriously and gave this idea a bit more scientific street cred, I think, is Nick Bostrom, my fellow Swede, Nick Boström, who published this very dry academic article just pointing out that...
He's a philosopher.
Indeed,
yes.
Indeed. Mm-hmm. And he pointed out that it seems like the laws of physics allow us to build amazingly powerful computers, way beyond what we have now, solar system sized things, which could simulate minds that would feel just like us. And then he went on to say, it seems overwhelmingly likely, if you don't wipe out here on Earth, that in the future, the vast majority of all computations and all minds will be inside of such a computer. And therefore, he said, if almost all minds are simulated, we're probably simulated. So that's the pro argument. Now, it sounds good, but...
So just to clarify, so what you're saying is if simulating universes becomes a pastime among those who have access to highly powerful computers, and we are in a universe, we are probably in a simulated universe, even if one of those universes is actually real.
Right. That's basically,
is that a fair?
That's the fair summary. Yeah. And if you're not sure at the end of the night whether you're actually simulated or not, my advice to you is go out there and live really interesting lives and do unexpected things so the simulators don't get bored and shut you down.
Is that the cause of death? Okay.
Now, in terms of the counter argument, if you just take Nick seriously,
that's the cause of death. My God.
There's something fishy here, because suppose you buy into this and you're like, okay, I'm sold on Nick's argument. We are simulated. Let's talk then about our simulated universe. We're measuring the laws of physics here in the simulated world. And we find that in the simulated world, we can build all these supercomputers in the future, and there will be all these simulated minds, and so on. And we can make the same argument all over again and convince ourselves that actually we're doubly simulated. And then we're a simulation in the simulation. And then you can repeat the argument again and say, well, okay.
Nah, this Max, he's a cosmologist.
There are going to be all these simulated computers, and they're going to have all these minds. So we're actually triply simulated. No, we're quadruply simulated, and it goes on and all night. And
the turtles all the way down.
All the way down. Yeah, and at this point, I get the sinking feeling that there's something rotten at the core of this argument.
Okay.
The answer is we're at level 42. That was
good answer.
No, 137.
137. That's the fine structure constant.
Of course.
And I think where the problem lies is that when you make this argument, right, about what kind of minds are really the most common, the simulated or non-simulated, it assumes to answer that you have to know what the actual laws of physics are. But if we start making these sort of arguments, we have no clue what the laws of physics are. It doesn't matter what the laws here in our simulation, if it is one, are. We need to know what the real laws of physics are in the basement universe. It's the foundation. And if so, we don't really have access to that. So that's this philosophical nitpick, which it seems to me swept under the rug here.
Jim, where
am I? Well, first of all, I have a finger, and I look at it, and it seems to be real. And so my point of view is very conservative. Carl Sagan once said that extraordinary statements, and I'm paraphrasing.
Claims, yeah.
Right? Extraordinary claims require extraordinary evidence. Now, Zora has told us about a kind of evidence, and that's the kind of evidence that would convince me as a
I'm
physicist.
finna show y'all.
But what I do is sort of a mathematical model of physics. And in our previous encounter here on this stage, I had a chance to tell you about these error correcting codes, which are a very specific kind of digital data. It's not just general digital data, it's a very specific kind, and it seemed extraordinarily unlikely. And I have to tell you that one of the reasons I enjoy talking to audiences like this is they get us experts out of our comfort zone. And so one of the first non-physicists that I talked to, or that I read reflected on my comment, said effectively, this is not exact words, but effectively he said, if the simulation hypothesis is valid, then we open the door to eternal life and resurrection and things that formerly have been discussed in the realm of religion. And the reason is really quite simple, because if you think about a computer, if we are a simulation, then we're like programs in a computer. As long as I have a computer that's not damaged, I can always rerun the program, right? So if you really believe that we are in a simulation and there's some structure that runs that simulation, unless something damages that structure, then we can be repurposed. And so it starts to break down a very funny barrier between what people often think is the conflict between science and the conflict between faith.
So what you're saying is that if we are simulated, that means there's a code that's doing it, and that code was started at some point, and in principle, it could just be rebooted. And then all of this would happen exactly the way it happened before, because it's running the same computer program.
Now remember, he said it would start with a code. Now, from what we see with life, does life not start with a code? Is DNA not a code? Life in general starts with a code. Who programmed it? And this is what we get into, is that we are living in something that has a programmer. And that's what they want to try to get around. They want to play the religious God games. Nah, nigga, we just want to strictly deal with it on y'all terms. Since DNA is a code, who the fuck programmed it? That's what we want to know.
If one accepts the simulation hypothesis as an accurate description of nature,
I would say that's a useless exercise. What would be more interesting is to actually...
The word was useless, Jim, in case you missed that. Okay, you heard that. Okay.
And just think, they're going to try to pretend like the coding that we see, because remember, mathematics is embedded into the universe. That's why we're able to use it as a language to understand it.
Emphasis on useless exercise. Go, Zahara, go.
Trying to repeat what you've already done with huge computational resources is useless. What is more interesting is to go and change the parameters of the simulation, the input parameters. Just put the same laws of nature, right? And then just change a little bit the value of the parameters, the very fundamental parameters of our universe, and then let it run and see what happens. And it's actually very interesting idea.
It's a fun thing to do.
Exactly.
As a scientist.
But in changing those parameters, you might cancel out my existence, in which case I don't think that's very useful.
The universe without Jim. So Lisa, isn't this some of the foundation? Couldn't we account for a multiverse in this very way? That multiple universes, as I understand them, will have slightly different laws of physics. Maybe they are themselves the experimenters' search.
So let's slow down a bit here. So first of all, I actually want to address some of the things that have come up already. One of the questions is probability, Bostrom's argument or whatever, that we're likely to be in a simulation. I mean, part of the problem is that probabilities have to have a well-defined meaning, or only useful when they have a well-defined meaning. So among all possible scenarios, we can actually say which one is more or less likely. When we run into infinities, when we run into, it stops making sense. I mean, I could say, really by probability, I'm very likely to be Chinese, because there's a lot more Chinese than Americans, but I'm clearly not Chinese. So probabilities.
That's a false equivalency. You are not likely to be more likely to be Chinese because there's more Chinese people on the planet. That would have to do with that you would have to put them into your gene pool and then say you would most likely be. But they're not in your gene pool, so that's a false equivalency. Terrible fallacy on trying to make that argument. Try again.
Are tricky, and you have to be careful what you mean when you're saying them. Another thing is, I actually find the egotism of thinking that if there were simulators around, that they'd come up with us kind of audacious and ridiculous. I mean, I think there's a very self-centeredness to this whole thing that kind of I find hilarious. And but in terms.
Let me take the banner down real quick. But do y'all see how insulting she is? And she the only one on there that look crazy. Like literally, she the only one on there that look crazy, and she's being insulting. It's really ridiculous, right? It's really ridiculous. And mind you, I just want to hear her explain where the code came from that started life as we know it. Where? Yeah, definitely. So let me see. Let me go back. This the lady right here that's speaking against.
Around that they come up with us kind of.
Right? She's the one that's against. The black guy in the middle is for. The three people to the right are for. The one guy right here to the left is for. And then you can basically say Neil deGrasse and the white lady with the shades, they're both against. Right? So they both kind of taking the negative in the argument. And this is all based off of Isaac Asimov work, right? So, and other work, basically, other work that they've done in their own personal field and their own personal experience. So, but it's just funny how dismissive, she really is about the whole discussion. And her first point that she thought was a bar wasn't even a bar. Like it wasn't at all. The first point she tried to make, it's just as probable. It's more probable that I would be Chinese because there's more Chinese people. No, that's nowhere near the argument that's being made. And the fact that you flattered yourself and laughed at your own terrible joke, and like it was bad. It was really bad, and it's only getting worse. And then what's even worse is she thinks that the crowd is laughing with her. But at this point, they've heard that first point that she tried to make when she unmuted, and now they're laughing at her.
Audacious and ridiculous. I mean, I think there's a very self-centeredness to this whole thing that kind of I find hilarious. And but in terms of in terms of feedback in terms of error correcting code, I think it's very likely that there are going to be feedback mechanisms in whatever universe survives, because if there aren't, I mean, there's always going to be mistakes. And if mistakes can propagate and just cut things off, those universes don't survive. So there have to be, I mean, for any universe, simulated or non-simulated, there has to be error correction. So that has to be part of it.
Right, that assumes that the programmer makes the same kind of programming that is susceptible to programming errors and programming bugs that we are.
It's not even intentional. It could be just that the computer itself is subject to error. I mean, it's only firing things somewhat random. I mean, ultimately, there's uncertainty in everything. Nothing is created perfectly.
Quantum uncertainty.
So
Can
is
I
quantum uncertainty,
jump in
is
here? Because
other uncertainty.
she's raised, in fact, I think an incredible
As long as you
incredible
come back
point
to me
about
afterward.
this. And may I take a few times? I'll see minutes back later.
Yes.
There you go. This point about error correction is something that when people have, general public has looked at my work, they say, oh, you must believe in simulations. And I've said, no, actually, I don't. And the reason is because precisely the point that Lisa points out. If you look in all of nature and ask, are there any other places in nature,
Yeah,
not
she thought that was a good point.
computers, things that we build, but in nature herself, is there a discussion in science about error correcting codes? It turns out there's one place and one place only that I have been able to identify. That's in evolution and genetics. And there's been a discussion.
Any biological system.
Right, or any biological, right. And it's not that we think life is some kind of programmed simulation. It's because the universe itself, as Lisa has said, has to have feedback mechanisms that basically sustain a structure that propagates faithfully forward in time. And I think that's, in fact,
She just died. You see how fast she just died? Because we see, what did he just say? We see it both in genetics, right? And in nature, what? Correction mechanisms that she said would have to, it would have to be some sort of way of correcting. We see that. We see that. We see it correct itself in order to continue the program as usual. Sometimes there's a glitch in the matrix, but for the most part, the program is going to run as usual. Same thing with DNA. There might be a, a virus that's throwing off the coding, but there is also something that'll run in you that'll go in and figure out that there's a virus, fight that virus off, and reprogram your immune system to function as normal. Like, this is what we talking about. Even when we got back, remember, we was just watching them reverse. We was just watching them change age. Remember, they was able to change they was able to make one rat younger and the younger rat older. They made the two rats the same age. They made them the same age. They made one older and made one younger by putting a virus in them that caused the DNA to break down and then restructure itself, reprogram itself. See what I'm saying? And then look, notice this is what we're going to continue to have to say: reprogram, which means that it was programmed from the beginning. And they want to try to play random games like it was just a random programming. Like motherfuckers just throwing shit up in the air and whole bodies is coming up. Oh yeah. Yeah, if you need me to show that again, Astro, I'll definitely show that. Yeah, they changed the age. They had two rats. One was older, one was younger, and they made them both the same age. Because that what happens is that the DNA is read like a CD, and they found that the scratches being left on it, if you could resurface the DNA just like you would resurface your CD, you could get it to play as new. And the scratches that come on that end up on your DNA from the epigenome, that's what causes shit like old age and blind, like the ailments that come with age and shit like that. Right? This is basically, and all this is basically that your once you start copying at a slower pace. Your computer is slowing down. Exactly. And a well-run computer will do the same. But you see what he tried to do? He tried to make it a religious argument. Well, that would mean that the programmer was making mistakes. And what he want to say is God don't make mistakes. We talking about a programmer. This is why you don't allow them to escape into the religious discussions, because he trying to make this about whether God is omnipotent, whether God is omnipresent. You know what I mean? All of this. This is what he trying to, he trying to slither into this argument. No, we just want to deal with whether we are in something that was created. And this is what they're trying to get around. He know that that's what it's telling. That's what physics is telling us. That's what quantum physics is telling us. That's what biology is telling us. That's what cosmology is telling us. But they want you to believe, oh, no, 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 because of religious dog, because they don't want you to deal with the principles. They want to get into the discussion about the dogma, our personal feelings about the programmer. Nah, we ain't finna get into our personal feelings about the programmer, whether he make mistakes and all of that. And that's all irrelevant. We don't know what's a part of the program. All we arguing about is whether or not there is a programmer, period.
At the most critical point. And you have your time now.
Thank you. And anyone who wants to take my time to agree with me. but as far as the multiverse theory goes, so we have to be careful what we mean by that. I mean, at some underlying level, we still think it's physics in action. Now, what might change in different universes? We might actually have different forces. We might actually have different strengths of interactions, the kind of thing that gets simulated. I mean, we simulate strong interactions the way that we're described.
Just to be clear, strong interactions are the forces
Exactly.
of atomic nuclei. And
So
you have,
protons.
Yeah, you have protons that are the same charge that are sitting right next to one another in a nucleus. And how's that even possible when we were taught that like charges repel? So there's got to be a really strong force down there holding it together. And there is a really strong force. It's called the strong force. Okay, so go on.
Which is strong.
Yeah, that's right. Okay.
It was programmed to do that.
So, and there can be different possibilities for what these parameters can be. It's still underlying, you still believe that there's the laws of physics that are operating. So the question, so it's not a simulation. It's just, it's in principle possible that there are universes we don't communicate with that are so far away, we'll never send a signal, they'll never send a signal. So for all intents and purposes, they're just.
And that's where she's lying. People connect with people on the other side all the fucking time. And this is why you can't become stupid, right? Remember, the dark side, we pull you out of your schisms, your isms, right? But we ain't just finna pull you right into another goddamn atheism either. We're not pulling you into no goddamn atheism because they just go too far. They just go too far. Like at the end of the day, right? Even when you look at how when you look at how atoms, right, or these electrons and different things, how they react when they're being observed, they still don't even know who the observer is. No different than when somebody their heart it has stopped, right? Their brain has stopped, but yet they're still able to collect data from everything that's going on in the room about them. Because the observation is coming from outside of the simulation. All of this is proving that you are not your body, but you use a body. Which that's the principle of all of your religions in the first place. It's not to get into the extras on how we personally feel about what that means and how that deters and how you connect with it. All of that is personal feelings and dogma. The underlying principle is that you are more than just a body. In fact, you use a body. And when you discard with this body, you continue. The body is only used to interact with the simulation. And the only way you can interact with the simulation is through the brain. But every now and then, which is why you don't separate the spirit, shout out to Northern Bella, which is why you don't separate the spirit or the spiritual form from the science. They both go hand in hand. So when you talk about being able to connect with different universes or different realms, it happens all the time. Like I said, even though there is a hard programming, there are still glitches in the matrix. Sometimes people who are transitioned are still able to are still able to communicate with this side. With and in other ways, you can communicate using mediums. If you are not a medium yourself, some people are walking mediums. So nah. They want to play it like like it's only one part of science. That's observable too.
Are different universes. That doesn't mean they're simulated, it just means they're different from ours and they can have different properties. To really distinguish a simulation, you really do have to see just our whole notion of the laws of physics breaking down, or some of the fundamental underlying properties. So it would be extremely interesting to look for the kind of violations of Lorentz invariance that were discussed earlier, or things like quantum entanglement no longer holding, not because of interaction with the environment, but just this computer just couldn't keep track of stuff. I mean, some stuff that gets so, I mean, a lot of the simulation idea, I mean, to simulate the universe, you need the computational power of the universe. So all of the simulations are based on the idea that there are some approximations that we don't see, that you have to be able to hide them. So so what we're really looking for is the breakdown of the assumption that those approximations are valid.
But David, what do your philosophical circles say about proposing an experiment that might falsify these ideas?
Look, I don't think you're going to get conclusive experimental proof that we're certainly not going to get conclusive experimental proof that you're not in a simulation. I suppose we could get some kind of very strong.
Well, why not? You just declared something. Why can't a clever person come along and
because any evidence that we could ever get could be simulated.
And that's I appreciate that.
Reason. I'm sorry. Maybe.
Okay. So if I find evidence that we're not simulated, the great simulator.
They could have just planted that for you.
Put that in.
Yeah, they're one step ahead. However,
okay,
maybe
we
probably could get pretty strong evidence that we are simulated. You know, if someone wrote up in the sky, "Sorry guys," the stars suddenly rearranged themselves into, "Sorry guys, it's all a giant simulation," and then they took over the internet.
Except it would be in Chinese to get the most number of people to.
Very good. Then we'd probably have pretty good reason to think we're in a simulation, either that or the weirdest non-simulated universe that anyone ever imagined. So I'm not, for a philosopher anyway, it's not fundamentally a matter of experimental proof. It's cool. I really like Zori's experimental evidence that we're in a simulation. But I think around here, it's really important to make a distinction. There's a hypothesis that we're in a simulation. And there's a hypothesis that the universe is computational. Those are closely related. If we're in a simulation, the universe is fundamentally computational. But it's not true that if the universe is fundamentally computational, we're necessarily in a simulation. Because the simulation hypothesis is a combination of two things.
That's an official thing, the simulation hypothesis.
Yeah. The simulation hypothesis is we're in a computer simulation. A computer simulation is a computation that was created by someone for a purpose. So basically, the simulation hypothesis is that computation hypothesis plus something else about someone who created it. And around here is where you might be able to get all theological and say, okay, well, it's a naturalistic version of a God hypothesis. But anyway, so my worry about Zori's stuff, which is really cool, it's really evidence for the much weaker hypothesis that the universe is some form of discrete computation, and it's completely neutral on the question of whether this is actually a simulation in the sense of something
with intent
is created by a simulator.
So Max, do you mind if I call you Mario from now on? Because if you're Mario in the computer game,
starts with MA, so I guess I get really grateful for the two letters I get. Yeah.
I imagine Mario, someone coming into a Mario game and calculating how high he jumps and how fast he runs, and coming up with the laws of physics of the game, and possibly then questioning Why is it that and not something else, perhaps? And so why would that allow someone in the game to have any understanding of what's outside the game?
Yeah, that's a really deep and good question. If Mario can never, even if he figures out exactly the rules of his world,
then he just figures out the rules.
He won't even know if he's running on a Mac or a Windows box or a Linux box, right? Because all he has access to is this higher level of this sort of emergent reality. We might, at some level, be stuck in that situation in physics also. It's quite fascinating to think that so much of what we figured out, for example, about how a glass of water works with waves and vortices and things, we figured out already without having a clue about the substrate. We didn't even know there were atoms, But the same kind of questions that you're asking, which I think are awesome, the kind of questions where you ask, suppose this is actually somehow simulated, suppose the simulator is cutting corners, how would that show up? Actually, it has been incredibly useful in the past. If you imagine going back 200 years and trying to simulate this water as an a continuous liquid where there's a pressure and a density that has to be defined with infinitely many decimal places and infinitely many points, that sounds horrible to simulate. So maybe whoever did that cut corners, maybe there's the smallest kind of chunk of object, let's call it atom or something. You can figure out then what are the kind of departures from this simplified continuous physics that I'm guilty of teaching my undergrads at MIT about this morning, and you would figure out a way. There's this one little thing which is different.
A few hours ago from Cambridge. Thank you for coming in.
Brownian motion, that things should jiggle around in a sort of weird way, and Einstein found that. Got the Nobel Prize for it partly. And I think that the sort of thing you're doing is awesome. Look for corner cutting evidence. I suspect that whether we're simulated or not, there are a lot of things that are wrong about what we assume today. I am very skeptical that we really have a continuous space that can be stretched infinitely many times. It seems like some sort of simplification that we came up because it was easier to do the math.
But do you ever ask why should that be the case? Why do we need a discretized universe? I mean, if you put away the simulation hypothesis or a computational hypothesis, why should we even think about it?
Yep.
Why not continuum?
So this is an important. I don't want to call it a problem in physics, but a reality of physics, that our macroscopic world looks continuous to us, and that has a certain simplicity of modeling. And then as you get smaller and smaller and smaller, it's no longer continuous. And it's discrete, which may be easier to calculate than being able to be divisible all the way down to an infinitesimally small bit. Because now you need that much bigger a computer to do it. By the way,
you know something that none of us actually know. This is actually a real question, whether space is discrete at really small scale.
Well, we run into this problem when we do flyovers in the Hayden Planetarium. We have a data set for a planetary surface, let's say Mars. And you're at a given distance, and from that distance you can see Olympus Mons, the biggest mountain around, and Valles Marineris, and you say, fine, now I want to get closer. Well, to get closer and have more information come to you, you have to swap in a higher resolution map. And we try to do that continuously so you don't realize that. So you keep doing this, and then you reach a point where we don't have more resolution to give you. So we actually hold you back so you don't go closer. But if you did, all of a sudden you see these discretized.
Did you just hear what he said? He just killed himself. But we actually hold you back. What's holding you back? How are they holding you back? Because it's programmed in there the same way the brain holds you back, by filtering out information, saying you don't really need to know any further than this. That's what the brain says. You don't need to know any further than this. This is the same thing that he's saying that they're doing with the maps. They fly in, they keep going, changing the resolution, and then they hold you back in the discussion. But let's let them keep going.
Pixels of the Martian surface. And that's basically because we don't have the data. We're not there. It doesn't exist for us.
So anyone who's used one of these virtual reality devices like the Oculus Rift knows there's something called the screen door effect. It's like you can see, if you look closely enough, you can see the pixels. So it's not a perfect simulation. So I guess really what Zora is doing is saying, well, we can get empirical evidence for a screen door effect in real physics.
Yeah, I think it's actually a deeper question than that. It's not about not having enough data to resolve those distances. That to some extent that's true, but the problem is that something that even bothered Feynman a lot, that why do you need infinite numbers of degrees of freedom or infinite amount of information to describe a very tiny chunk of a space-time? That just doesn't make sense. You can pretty well describe the physics without actually needing that infinite amount of information.
What I meant to add is that when we're zoomed down to Mars, it's not only that we don't have the data, even if we did have the data, you would need that much bigger disk space to have it ready and loaded to be able to go from a
Peace and y'all, mate.
eye view down to any kind of small, I mean, we rapidly run out of capacity to calculate.
And that's a great controversy that even mathematicians have been really arguing passionately about for over 100 years. Like Gauss, one of the greatest mathematicians ever, said, or Kronecker actually said that God created the integers and everything else is just the work of man, and all these continuous real numbers with decimal places and stuff. And I mean, frankly, as a physicist, it feels kind of hubristic that even though to say that you need an infinite amount of information to figure out the height of my wine glass or anything. Nature seems perfectly.
There's water in that glass, by the way.
What to do, and yet, what?
But no, what he was saying though with the Oculus, right? So what he was saying is that when you in the Oculus though, it's not the picture ain't as clean as you would think it would be, and what he's saying is that it almost gives the screen door effect, where you can kind of see the pixels. And so right now, the way that the world is programmed, we can't see the pixels. But what the first lady was saying, right, the astrophysicist, was that when these different energies pass through, like remember she was talking about the different rays, right? These different rays that they can't simulate because they are just very high energy. When they are warping the time-space continuum. And so if they are able to, if they can actually observe those, they can observe the universe through those, right? Or by observing those, then what it would give almost, what he was saying, it would give almost a screen effect. So when during that time that these different energies that pass through the earth are warping through time and space, if we can view through them, then basically it would be similar to us being able to see the pixels in the Oculus. You know what I mean? It would be similar to that. It's just that, which is one of the reasons why she was saying it's just even like when they trying to observe the universe down to the smallest point, it takes too much information, which that goes against the normal laws of physics. The more space you should need, the more space you have, the more information you should need. But instead, you're needing more information for less space. And so that's why which is why they've already came out with the theory that the Earth, that the universe is either a time continuum or it's eternal, which is even crazy, or it's eternal.
We have this toy model that you need an infinite amount of information to do things. I think you're onto something very deep there, Zora, and that nature actually, that infinity is just something we made up for convenience. And as we dig deeper, we're going to find.
I hope I explained that well.
Space and time itself comes in, is at some level digital.
So can I just say something by way of clarification, which is just in physics, we don't actually prove any theory. We can rule out theories. So you can rule out a lot of alternative theories, but in any case, you can always have the possibility that you can dig deeper and find that whatever theory you thought was the most fundamental has some underlying structure. And so that's why all the physics we've done works. That's why we really don't need to have an infinite amount of information at any time because we don't have access to an infinite amount of information. And we can't even ask the question or tell whether or not there's this underlying infinite amount of information. So it's not just, we can't just ask the question whether the universe is simulation. We can't ask if any physical theory is absolutely correct. We'll never know the answer to that. All we can know is that we've tested it up to a certain level, at a certain level of precision, over a certain range. And so these questions all come in, and that's why I can describe this glass of water without knowing about atoms, because I wasn't doing an experiment where the effects of the atoms became manifest. And the same might be true of the universe as a whole. So we can have in the back of our mind, there may or may not be an infinite number of degrees of freedom, but that's not what we're actually testing.
Just to disagree on one thing, though. I think there's one fantastic example where we can tell it makes a huge difference. I think the biggest embarrassment we have, arguably in fundamental physics and cosmology right now, is this fact that inflation, if it goes on forever, it makes this multiverse, and then we can't calculate probabilities, like you so eloquently said in the beginning. That comes exactly from the infinity assumption. The idea that you can take a piece of space and just keep stretching it into twice the size, forever. So
well, it
I
doesn't
think we
have to
should
be
question
infinite.
that.
It could just be a large number. It could be 10 to the 500. I mean, it doesn't really matter if we say it's infinite or we just say it's a lot.
But you can calculate probabilities as long as it never gets infinite. It's exactly the infinity that kind of...
So he's cool with 10 to the 500 is what he's saying, which seems like a really big...
I know.
That like equals infinity to me, I think.
But that's exactly the point. That's exactly the point.
Jim, is there any functional difference at all between admitting that we live in a computer simulation and saying that that's basically a secular God? What's the difference?
Well, first of all, I've decided my name should be Morpheus, not Jim.
Okay. Well,
I'm Mario. Nice to meet you, Morpheus.
Morpheus.
Exactly.
Yes. You have to see the movie Matrix and play video games to follow this conversation at this moment.
But
Morpheus.
But as I said, for non-scientists, because I'm going to make this partition, I think for non-scientists, an acceptance of the simulation hypothesis as an accurate view of our universe is equivalent, I believe, to the notion of a deity. I don't understand how for non-scientists you can make that distinction. For scientists, however, we are rather secular. The definition of science is actually
Intentional angel numbers.
And in fact, it's the definition that comes to us from Galileo. Einstein quotes Galileo as being the father of all science because Galileo, and this are Einstein's words, drums into us that contemplation alone, without observation of nature, is totally useless in trying to come up with an accurate view of nature. So it's the ability of us, our human ability to observe the universe that actually defines science. So if you can't give me something that I can observe, I don't know how to do science.
Okay, so what you're saying is that if in fact there is a programmer who would be philosophically equivalent to a creator and you can't observe them, they're just outside the realm of science.
I think that's a definition.
David, you have to be defined by that.
Well, I think there's a theological reading, if you like.
Exactly. Because the only thing that you could do is find evidence that you were in the program. But you won't be able to see the programmer from in the program. The most you could do is notice a glitch is in the program or some type of way you testing out the limits of the program. You would end up realizing that, I'm in a simulation. That don't mean that you're going to be able to see them from the simulation. You would have to be outside of it. But what you're going to find is that what's outside of the simulation is mind, consciousness, intelligence. Remember, you get the problem, right? You get the critical thinking, and then you get the solution. That's your holy trinity. That's how you get us. You're negative, you're positive, right? Your negative, your positive, equaling the solution.
To the simulation hypothesis, it says all this was created. But what's interesting is it's, at the same time, it can be seen as a kind of a naturalistic
Yep.
a naturalistic hypothesis from the point of view
Is that the first time the phrase has ever been uttered? A naturalistic theology?
I think it's out there already.
Oh, it's out there. Okay, good. All right.
Simulation theology. You heard it first. Simulation theology is the coolest kind of naturalistic theology. From the point of view of
Actually, there's a book in 1750, or who was it?
Yeah, David Hume was into.
No. There was who was the fellow who wrote the book, the Natural Theology? And there's a book with that very title.
Yeah,
but not natural simulation or simulated theology.
If you think about it from the point of view of the simulated, I mean, we in this universe can create simulated worlds, and there's nothing remotely spooky about that. You know, people are already doing it with virtual reality and The Sims and Second Life and whatever. This is just a far more sophisticated version of that. So we just need to move that picture to the next universe up and say, hey, maybe that's what's happening to us. So we got a creator, but our creator isn't especially spooky. It's just some teenage hacker in the next universe up. Mom's calling him into dinner, you know. So
working in the basement, yeah.
So I think you could be led to at least entertain this idea by perfectly naturalistic ideas, as say Nick Bostrom was, and say, okay, maybe this is the kind of theology which even someone who's got no sympathy for spooks and gods and ghosts needs to object to.
So that's an interesting point, because we don't think of ourselves as deities when we program Mario, even though we have all power over how high Mario jumps, because that's a line in the code. So you're right, you just take it up a few notches. There's no reason to presume they're all powerful, other than just they fully control everything we do, say.
It could be they're all powerful. I got into this from watching my 5-year-old nephew playing with one version of The Sims or Sim Life or something. He'd make a whole town, he'd build up the buildings and get the trees and the jungles and the creatures, and then he'd say, now comes the good part. And he'd send down fires and floods. And so it's like, finally, I understand the God of the Old Testament.
So you're saying
because it is true in our world, we have fires and floods. I played one of those Sims, Sim City, because I'm a city kid, and the early low res simulation. And there's a feature, you build up you need money, you're mayor of a city, and you construct buildings, and you need the schools and the fire departments. And then every now and then, Godzilla stomps through your city. And you say, well, that's not real. I'm trying to be real. But then it's kind of real in the sense that some major disaster you will confront, like Hurricane Sandy or 9/11. Now you've got to redistribute resources. So I look at our real world, and these things actually do happen. So are they just trying to mess with us? Is that?
Well, the way I think about, I mean, who knows whether there's actually a simulator who's actually doing any of this. But if you do take the simulation hypothesis seriously, it's got a couple of elements of a traditional God. This person could be all-knowing about our universe, could be all-powerful. The one thing which is probably missing is wisdom and benevolence. And, if there's a simulator, I refuse to worship you. You may be out there, but you have not established yourself as being worthy of worship.
Right, because they're all powerful, all-knowing, but not all good.
Give him
Right,
There's no reason to think they're all
Cut him
good.
some slack. He's only 5 years old.
You better be maturing one of these days.
Zohari.
I think there is a big danger in trying to compare our idea of simulation.
I don't think it's too smart to mock the programmer, but okay.
My point of view, and I think a physicist's point of view, what calls the simulation is you just input the laws of physics, and the nature and universe emerges. You don't actually try to make it look like it's something going on. You don't try to the same as with the computer games. You don't interfere with what you've created. You just input something that is very fundamental and just let it go, just as our universe. So I think
like
there
deism.
I think if you take,
in other words, you set the laws into motion and let the universe unfold, however those laws prescribe.
Because a priori, you don't know what happens, because the universe is complex. The laws of physics are simple, but you don't know what kind of complexities you should expect. And then you just let it run, and things emerge, and you just watch.
But Lisa, in the search for the theory of everything, Isn't that got a little bit of this in it? Once you find the theory of everything, and you've been on 2 of our theory of everything panels here, you're going to find out the one equation that the 5-year-old working in the garage wrote down that made our entire universe.
Well, you might recall, since I've done this a couple of times, that the theory of everything, I think, is very badly named for a lot of these reasons. Because even with the equations, as was pointed out earlier, you could start your system very different ways. You can have different conditions. And there's a lot that we don't understand. I mean, even if I understood at quantum gravity at a fundamental level and could derive all the equations, that's still not going to help me predict waves at a practical level. I mean, the computer simulation will never be that detailed, in my opinion. It's much better to go to different levels and figure out what's going on at what I would call an effective theory approach. So even with the fundamental equations, now sometimes, I mean, clearly if you had infinite computing power, then you would just be literally mimicking the universe, and possibly you could do that. But short of that, you're going to have to find these approximations, these descriptions that are sort of somewhat in between. They're still science. They're not something I'm just making up. They're still equations that work, and they ultimately are attributable to whatever is that fundamental equation. But that doesn't mean it's fundamentally how we're computing it. It doesn't mean it's fundamentally how it's working.
But Zara, you started this whole discussion by describing trying to attain an understanding of the basic forces of nature and the particles and build up from there. But isn't there surely a gap between what you know drives the behavior of individual particles and what might be emergent features in a macroscopic system? Isn't that true with the gas laws? We learned gas laws in first week of chemistry, but I don't know that you can get the macroscopic gas laws by knowing every single particle at every single instant. I don't know that they're fully reducible to that. So can you admit the possibility that there are gaps and that there's emergent phenomena so starting at the very basic level won't get you there? Is that possible?
I do admit to that, and it is in fact a
Okay,
gap
good.
in our-
Thank you. Admit to it.
No, this is indeed a field of research now. For example, in nuclear physics, we know these microscopic features about particles and building blocks of that contributed in strong interactions, but we don't know exactly how to get this complex system of nuclei. So, and we have very good microscopic and phenomenological models to describe all these larger scale phenomena, but we still don't know how to get them from this phenomena. So that's what, as physicists, have to.
If you could do it, I mean, if you had infinite computing power,
yeah,
in principle, you could actually see a system that exhibited the gas laws. The question is whether we as scientists would call them deriving the gas laws. It wouldn't be a very useful description. It would mean that we'd have to have these enormous computations every time to do it, rather than solve an equation that, as you know.
Oh, so I never heard that before. You're assuming that if in fact we could compute the behavior of every single particle in a gas, that out of that would emerge the macroscopic gas laws.
Well, it would behave according to the gas laws. That doesn't mean that you would
okay,
know what those gas
that's
laws are.
confident. So what you're saying is it's not emergent, because I'm intrigued. Which of you mentioned the water?
Emergent means it emerges from the fundamental laws.
Because we understood to a very high degree fluid dynamics long before we knew that fluids were made of atoms.
Right.
And I don't know how much the public knows that atoms are, though the idea is old, evidence that atoms are real is relatively recent. And even in as recently as the year 1900, it was still kind of not sure.
Right.
And
think about that. This is what I be talking about. Atoms was a part of philosophy since the Roman days. They literally, like literally in the Quran, Allah said the first thing that it speaks of is Allah splitting the atom from the nucleus. Like they already had these concepts and we're already studying it or philosophizing about invisible particles that they wouldn't see for almost 2,000 years, that they wouldn't be able to observe for almost 2,000 years. And so, yeah, he putting that into perspective. Could it just be that the same way that we knew that atoms existed, even though we had no evidence until recently, could it be the same way a programmer, we can know a programmer exists without there yet being the evidence or complete evidence to prove it? Or should I say us not being able to observe it? We'll see.
And it wasn't really until Einstein and Brownian motion in 1905 where there's really good evidence that atoms were real things. Yet we had full understanding of fluid dynamics in any way that mattered for us.
But I think we also now can derive fluid dynamics from the atomic description in certain cases, not all of fluid dynamics, but some of the properties of condensed matter physics we can derive.
Okay, I'm glad to hear that. So we're still talking about reducible things.
They're two separate things that we mustn't conflate. On one hand, I think in principle, one can derive all of these higher level things. I think ultimately even consciousness, like David Chalmers is working on, from starting out with the quarks and stuff.
You're going to bring consciousness into this?
In practice, on the other hand, whether we humans are smart enough to figure it out, that's a whole different story. And I think that's...
You can't leave consciousness out of it.
In saying that there's some mysterious epistemological gap that we can't...
Oh, no, that's not what I meant.
But that we might not be able to understand.
We haven't yet have the resources and probably enough tools and understanding to fill that gap, but the fundamental equations are there. It's just a matter of when we actually get there. So
I'm curious. This brings me to a point that we did not discuss earlier in the notes that we shared. When I think of emergence,
exactly
everything you can about cell biology, about how life works. And it's not obvious to me that by just studying a single...
The only part of you that you can't prove
evolution by natural selection
literally comes from the universe is the intelligence.
In the system. So...
And that's because it's what created the universe.
That's just something that resulted.
Right, so the way I would describe it is I'd say that the fundamental, whatever is fundamentally there, that substrate is essential to whatever happened, but it's not necessarily essential to your description of what happened. And so the laws are following from this, but it's not giving an explanation. So I can note that there's atoms, but it doesn't help me predict what will happen when I throw a ball. I mean, in principle, I could probably figure it out based on that, put it all together, but it won't help me. It's so inefficient. So it's much better to have a description of a solid ball, even though it's made of atoms, which are actually mostly empty space. So that solid ball description leaves all of that out, and it works just fine. It tells me exactly where the ball will land.
David, you and your consciousness cronies, is it generally recognized that consciousness is an emergent phenomenon of a complex brain?
Yeah, well, this word emergence is kind of a word that people use to cover a huge variety of sins. I mean, sometimes I think it's a kind of
exactly
used to make ourselves feel comfortable with things we don't really understand. Say, it's emergent. There's different kinds of emergence. There's the kind you get with, say,
like emerge from what?
The game of life, Conway's game of life, where the cells blip on and off, and you get complex phenomena like gliders that move along. Yeah, it's surprising. You wouldn't have expected it. But you can put together the equations, and it's totally predictable. You run the game of life over and again with simple computational rules. It'll be predictable again and again. Evolution is interesting, intermediate case. Maybe given the laws of physics and certain initial conditions, you can run them again and again. I don't know. Maybe it'll turn out evolution arises 60% of the time. If so, that's incredibly cool. And then that ought to be explainable in principle. Now, for consciousness, people sometimes say consciousness is emergent, but there's a gap there of a kind that we haven't even begun to close in the gap of consciousness. People can tell stories about life. People can tell stories about evolution. No one's even begun to tell a story that enables you to predict the existence of consciousness from any number, any amount of underlying physical dynamics. It explains the behavior. It explains how we walk, how we talk, but why that should actually feel like something from the first-person point of view, that is emergent in a much stronger sense. I'd say that's strongly emergent in the sense of it might require new principles to explain.
Max, is there any role of chaos theory in this? Because we know that in principle and in practice, there's some systems that are so complex that you cannot accurately predict its future behavior. Now, is that true even if you had an infinitely powerful computer?
No matter how powerful a computer we build on Earth, we can certainly not predict. We could not have predicted that the Red Sox were going to win the World Series right after they moved to Boston, because precisely of chaos theory, where tiny changes in the positions of some particle, made a huge difference later on. But
just the butterfly effect.
Yeah, if things.
I got to tell you real quick. There's the Journal of Irreproducible Results, which is, if you're a scientist and you come up with something that you know isn't right, but it's a really cool calculation, you publish it there. And it's like, in there you'll find the calculation of what happens if you strap a jellied toast to the back of a cat. Since toast always lands jelly side down, and cats always land on their feet, what would happen if this dropped, okay? And so in the paper, they hypothesized that the cat falls and then hovers over the ground. So it's stupid fun calculations. One of them was, sorry for this interlude, but one of them was, there was some major storm system that happened that hit the east coast of the United States. And someone said, we found the butterfly that caused this. And it's like they killed it and it was on display. So go on. So this butterfly effect.
Yeah. It was apropos complicated emergent phenomena related to chaos and such. I just wanted to come back to what David was saying about consciousness here and kind of connect it with what you opened with here. How can we test with scientific methods these ideas of whether we're simulated or not, or at least update our odds in one way or the other? I think one thing that's great to do is what you're doing, again, looking for this evidence of the simulator cutting corners to make the simulation easier to run. I think another thing we should do is, if you want to test this computation hypothesis that everything is a computation or that everything is mathematical, we should look precisely at the things where we're the most clueless right now about how we would actually describe it mathematically. And I can't think of anything we're more clueless about right now than consciousness, and try our very best to see if we can bring also that in under the tent of things that we can describe with math. And if we fail spectacularly on that and can realize why, we'll see.
Good night, sis. Appreciate you.
Mathematical. Boom. Done. Death to the simulation hypothesis. Whereas, if you and your cronies, as we're told, what they're called, succeed, that would, I think, be a big boost for the simulation hypothesis.
And there are people who are pursuing the idea, as you know, that consciousness is fundamentally about information processing in the right way. When information,
I'm gonna keep this short so y'all have a lot to have to replay.
A kind of consciousness. That's still a very controversial idea and a lot that it doesn't explain. But if something like that is right, it goes very naturally, at least, with the simulation hypothesis, because it's very natural to suppose that in a simulation, there could be all that information being integrated and giving you consciousness. Certain other views, just say, for example, consciousness requires a certain very specific intrinsic property, like a certain specific biology. Then there could be a simulation of the whole universe, but if it didn't have that biology, then no consciousness. It would just be a world of unfeeling zombies, unfeeling physical dynamics. So it really makes a difference.
How do you ever show that something can't be described mathematically? You'd have to believe that you understood fundamentally what the degrees of freedom are. So you might just have the wrong description. I mean, even in physics, I mean, we know classic examples where people thought certain things were impossible until just a new law of physics was discovered. I mean, Darwin got the age of the world, our world, closer than the greatest physicists of the time, because Darwin just looked around and Kelvin thought he knew the laws of physics and he didn't get them right. So I don't see how you're ever going to be able to show that something has no mathematical description.
Wait, Max, you're big on the mathematical concept here.
You heard what he said? One person was closer by just observing the universe with his eyes, and the other person was well studied it. So you can't dismiss either.
In answer to Lisa's question, David put it very well in the beginning. And physics, we aren't ever able to really prove that something is true. The only people who prove stuff are mathematicians. But if David and Giulio Tononi and Christoph Koch and others succeed in this endeavor to try to actually explain consciousness mathematically, it wouldn't prove that things are purely mathematical, but it would certainly be yet the great boost. Because if you just go back, let's go back to Galileo again. We were eulogizing him earlier, right, for his great insights. And when he wrote that our universe is a grand book written in the language of mathematics, that was 400 years ago. And because he was so impressed that things moved in parabolas and things like this. And he had no clue why oranges were orange and hazelnuts were hard and some things were soft. That seemed like it was beyond what you could do with math. Then we got Maxwell's equations, the Schrödinger equation, the standard model of particle physics. More and more has been explained by math. I think Galileo would be really impressed if he were on stage. So it's really cool to look at what are the things left.
I'll invite him next time.
Failed on. But you can reincarnate him and bring him on.
So we'll just have to simulate him. That's what we'll do.
To look, okay, what's left? Like consciousness, for example, and see if we can also make some progress there. There's no better way to fail on anything, including consciousness understanding, than to tell ourselves, we know it's impossible because of some principles, so let's not try.
Yeah, those aren't good scientists who behave that way.
I think we have to distinguish, though, between the two claims that you can give a mathematical description of everything and you can give a complete mathematical description of everything. I mean, even consciousness, you can obviously give many mathematical descriptions of, color space has certain geometrical properties, the light, the feeling of the light is more or less intense. You can give a very rich mathematical description of it, and that's what, say, someone like Tononi is doing. But can you give an exhaustive mathematical description of it? Once you've given a full mathematical specification of consciousness, have you understood everything about it? Or is there some further nature, like the redness of the red or the blueness of
What Max is saying is that previous frontiers in that question were ultimately breached when enough smart people came along to figure it out. So whatever's our state of mind today, it would be unwise to suggest that it somehow transcends any access that the future of math might.
At some level, we don't have an exhaustive description of anything because we understand that there can always be something more fundamental, something we haven't seen yet.
I agree.
In fact, the very word atom in the Greek means indivisible.
Yeah.
So, with that,
but while
how long did that last? Yeah.
While we have been all bowing at the altar of mathematics, a number of us are aware of this result by Gödel called the incompleteness theorem. And it even says, in some sense, mathematics is incomplete. There are things in mathematics that you cannot prove. That's what the theorems say. And so we, as humans, I think...
In fact, Gödel proved it.
Yes. Yeah, right. He proved it. That's exactly right. He proved
Gödel
it.
proved that math cannot be proven.
That's right.
Yeah.
If it's consistent.
Right, if it's consistent.
In defense of our universe here,
somebody's got to defend our universe, so go ahead.
Standing up for our universe, there's absolutely no evidence that our universe is inconsistent or that mathematics is inconsistent. Gödel said that we humans, we cannot prove ever that mathematics is consistent. We cannot prove that it's impossible to prove that 1 equals 2. But I think that's probably more of a reflection of our own the limitations that thinking beings have, rather than that our universe has some kind of identity crisis. The thinking beings.
Wait a minute. Did y'all just hear that? Because now we got to go back to the Terrence Howard. Because wait a minute now, that does raise the question. If you saying we can't prove 1 + 1 is 2,
It's impossible to prove that 1 equals 2. But I think that's probably more of a reflection of our own the limitations that thinking beings have, rather than that our universe has some kind of identity crisis. Our universe seems to know exactly what it's doing. It doesn't seem very inconsistent, except when I watch presidential debates.
Yep, that's James Gates.
Going there.
What's good with you, Alcatraz?
Yes, that was precisely my point, that maybe what we're talking about is in fact part of our limitations, not limitations on the universe. But, in science, it's very funny because the way we do science, when I give public talks, I like to say, if you look at a family in their house, you might be an anthropologist and record what they do and they turn the appliances off and on, and you might come up with some big record book of this. But then when everybody's out of the house, you might just go to the house and watch how it behaves. You know, the thermostats go up and down, and, you know, maybe you have a timer that does other things. And so the house has a set of rules for operating when you're not there. And in some sense, in science, that's what we're kind of doing. And when we do this kind of split between science, non-science, in some sense, we're talking about how the universe behaves as if we could take our consciousness outside of the universe. And that's a very subtle point to appreciate. And so maybe what this whole discussion has been about is actually just our limitations.
So we're all stupid, is what you're saying. Yeah.
Actually, the universe made us very clever, at least most of us.
So Jim, I got to ask you something. Your discoveries of the sort of checks, error correcting code within the laws of physics themselves at the depths that you're researching them is what I wonder is we live in the age of IT, of information technology. So we all have a certain fluency. So it's in our brains to think that way at some level. Could it be that, you know how the saying goes, if you're a hammer, then all your problems look like nails, and you solve them by hitting them. If now we are in an IT revolution, and you're finding IT solutions to your problems, maybe it's just the fad of the moment, and that you're forcing a solution that is either not real or there's a better one awaiting in a revolution that has yet to occur.
Sure. So the last time I was here, I actually misspoke. I used the name of Shannon when I meant Hamming code instead. So first, let me correct that for this wonderful audience.
Error correction in action.
That's right. Error correction in action. Absolutely. But in our work, it's, first of all, we don't know that it's the physics of our universe. There is a large experiment underway that Lisa knows a lot about in Geneva because she has written papers about possible outcomes in these observations.
Lisa, are you flying to Geneva tomorrow?
I am, but not for that.
Not for that, okay.
So the Large Hadron Collider is going to explore more of the structure of the universe. So first, the mathematics that I have done will only become physics or relevant to nature when the LHC or some other observational device says the idea of supersymmetry is correct. Then it will kick in. So that's a big if. There are lots of physicists that don't believe the universe will be supersymmetric, in which case all I've done is an interesting mathematical fairy tale.
So supersymmetric proposes a whole other regime of particles that are counterparts to the particles we've come to know and love?
Correct.
Okay, and they're yet to be discovered, but they could be describing a whole other parallel reality awaiting our discovery.
But even that, I mean, I just want to.
Well, we already know that exists, right? Because for all particles, there are antiparticles. Or for all matter, there is what? Antimatter. Antimatter.
To clarify, we may or may not find evidence at the Large Hadron Collider, which is what's being discussed, but that doesn't even mean that supersymmetry doesn't exist. It means that we can't find the evidence at the scales that we can probe.
Exactly.
So it could be that there is some fundamental symmetry and it's broken at such a high scale that we cannot access any of the evidence of it. And that's the world we live in. I mean, that's what we do as scientists. We try to simulate what we can, we try to derive what we can, we try to measure what we can. And then we have to allow for the possibility that we just haven't had the accuracy, we haven't had the cleverness, or we haven't had the resources to be able to test certain ideas. And so I think that's right, that it's a combination of what's out there and what we can actually do.
So I don't know who among you to ask this directly, so I'll just put it out there in front of you, like a piece of raw meat, and you can just chase after it if you, or you vegetarian, some raw carrots, okay? So you can chase after it. I don't know if any of you are vegetarian.
Can you cook the meat at least?
I'll cook them, okay, we'll cook the meat. My question is, I remember Physics 101 and then 102 and 201 and 202. And as you learn the laws of physics, every now and then something pops up that's just kind of weird. All right, you learn Maxwell's equations, which describes the behavior of electromagnetic radiation, the behavior of light. And they're really beautiful, except there's an asymmetry in there. There's like, You can have particles that have electric fields like electrons, but you don't have isolated particles that are their own magnetic fields. There's always a plus and a minus stuck together. So they're not symmetric that way in the equations. And it's like you cringe when you see that, because part of us wants some beauty and symmetry to the universe if it is, I don't know, we're holding it in very high, we're holding very, very high expectations for what we want to find. And then you go back to the early universe and you find out that 1 out of 100 million photons did not become a photon because symmetry was broken and it made only one matter particle. Whereas all the other interactions had matter and antimatter, they annihilated and became photons. And we are made of this 1 in 100 million stuff that's left over. Something broke in the early universe. And I ask you, why aren't these bugs in the program that we're dealing with?
Think about what he's just said. Matter and antimatter exploded and became what? Information. Photon. Light. Information.
With?
So I'm going to actually answer that.
You got an answer for that. Very cool. Very cool.
So it's definitely not a bug in the program, because in both these cases, the underlying laws actually do exhibit symmetry. As Jim knows really well, that it has to do, if in our description of electromagnetism, you have electrically charged particles. There's an alternative description where the fundamental particles would be magnetic. That's not the universe we find ourselves in. So a lot of the symmetry is broken by the actual state of the universe we live in. So it could be that the laws of nature have some underlying symmetry that gets broken at some point.
So who's breaking it?
Who's breaking it? The universe. The universe is
that's not the answer. I'm looking for a little more insight into who's breaking the laws of the universe than just the universe.
Well, here's a simple example, okay?
Well, just to be clear, we come up with what we say are laws, and then if we see an exception, we say that there's a case where the law is broken, and we're okay with that.
Suppose I have a pencil.
So sorry, symmetries that are
broken.
broken.
Suppose I have a pencil standing on end. I have rotational symmetry, right? We'd like to believe that everything's rotationally symmetric. Why should one direction be different? So I have a pencil standing on it. It's going to fall down. It's going to fall down in some direction. Now, who made it fall down in that direction? No one made it fall down in that direction, but it was going to fall down in some direction. So the symmetry is broken. We didn't ask the symmetry to be broken. The fundamental laws were perfectly symmetric, but the symmetry is broken. And there's many things in the universe that are like that. The fundamental laws are symmetric, but the actual universe we live in has broken.
So we can't look for weirdness, because if it is a program that's running, which came up earlier, and we all had programs that crashed, what happens if our program crashes? Do we all disappear, like instantly? What are the consequences to this being a program if someone unplugs it? If there's a bug that crashes the entire system? Is there any piece of the universe where that part of the program failed?
I have it on good authority.
Spinning wheel here on the stage going round and round and round.
I have it on good authority. It's crashed 5 times during this panel discussion, but fortunately it rebooted perfectly, and we have no memories of it. So that's just good error correction.
No. So, but Neil, the point you raise, in fact, is for me one of the most uncomfortable ideas about the simulation hypothesis, that it's running on some device, and that the errors would then, how would it manifest itself?
Hey, I'm gonna say this, man. The dude with the British accent had no reason to really be there. Bro has not added anything but these lame jokes that he keeps trying to crack. Like every time somebody, like Neil deGrasse raises a question, it's like, bro, what are you doing right now?
Well, in the way that I think most of us think about it, it's kind of the end.
And I'm gonna say this: what Neil deGrasse is raising the question on is like, so every time we see a glitch in the matrix, you just wave that off like, oh well, it's just, it just is what it is. He like, well, that is pretty damn convenient. That's pretty damn convenient when we got laws and symmetry But then you say that the universe it'll just break those laws, and we just overshadow it. Like, well, it just is. Well, it's just like the pencil standing up. Like every analogy she's used has been horrible. It's just like the pencil standing up. It's gonna fall down. Nobody said what direction it was gonna fall or forced it to fall or anything. It's just gonna fall in some direction. Like, no. The pencil was not made to stand up. What the fuck? Like, why does she keep making these false equivalencies? The correct way would be if the pencil was made to stand up, and then out of nowhere it just fell. That would then say, "Oh, nobody made it fall. Nobody da." But we're talking about things that were made with a certain law to it, and you saying that the law just got broken, and you comparing that law being broken to a pencil that failed that you tried to stand up. Like, what are you doing? And like Neil deGrasse is saying, this is a fair. And if you look at how he's moderating, he's actually being fair. He's making a valid point. Every time we see a glitch in the system, you just gonna wave it off as, oh, it's just the system. That's what we trying to say.
End of the universe. And for me, the universe that I have studied for 50 or 60 years is it's a place of mystery, but it's not a place of the fundamental kind of insane, unleashed chaos that kind of end. Now, we know that we talk about, for example, false vacua. That's something, again, that Lisa knows a lot about because it was pioneered largely by Sidney Coleman, a professor at Harvard before Lisa got there. We know that these possibilities are out there, but the breaking of the symmetries are one thing that's really odd about this is if you don't break the symmetries, you don't get us. You don't get a universe with creatures like us in it unless you break these symmetries. And so maybe the question which
is like, why did I break those symmetries?
That's right. The simulation of why am I breaking those symmetries? So, the fact of our existence says something very deep about the mystery of this place we call the universe. Because the laws, the symmetric laws, they're beautiful. We write them with simple equations on 1 or 2 lines. But if those laws held exactly, we're not here.
In fact, it's just a universe of photons.
I think that's a
Right. Like salt and sugar just randomly becoming a blueprint to create life. Shit like that. That's what he's saying. If something had to break the symmetrics and how the program functions, what's good with you, Markeith? In order for you to even get DNA. That's what he's saying. In order for you to even get DNA, there had to be a break in the in the symmetry. Otherwise, we wouldn't even be here. So every time there's a break in symmetry, you can't just fucking wave it off. Just not something it's just a break. It just happened. It's just like a pencil that you set and tried to stand up. That ain't supposed to fucking stand up. Like, why? I don't know what she was doing here. I'm just gonna be honest. They needed somebody else in opposition because she never made a valid point, not one time.
very good point you bring up there. At first, it looks like if someone simulated this, they had been drinking too much or whatever. They were really wasteful because you might ask, like, why, if they just wanted to simulate us, did they bother simulating all this dark matter, 6 times as much matter? Obviously increased their CPU cost, but they had to pay for their Uber cloud services, whatever,
Right.
It came really late in the universe.
But every single thing we've discovered, like dark matter, for example, that seemed superfluous, we've since discovered that if it weren't there, we would be dead. Or in fact, we wouldn't even have evolved in the first place. If there were no dark matter, for example, then its gravity would have not been there to help pull our galaxy together, and the Milky Way wouldn't even have existed. So it's an interesting question, I think, to ask, is this the simplest kind of simulation you could run that would actually get some interesting life? Or is there something in our universe which is really just bells and whistles that you could optimize out?
So maybe they're just running someone was just doing this kid was doing a science experiment. He ran 1 million simulations overnight, and exactly one of those universes produced, broke the symmetries in the right way to produce conscious beings. And hey, here we are.
Why did they make chiral fermions so difficult to simulate on the lattice?
That's a scientific question, you guys. So
maybe
Hara, yeah.
just adding something to this, instead of just looking at the weirdness and that we observe in the universe, some maybe more fundamental question to ask, again, we can ask why the parameters of our universe, the mass of the electron or the cosmological constant and things like that, why should they have the value they have? I mean, in terms of the simulation scenario, you can sort of start to think this is just an input as many other input. Or the other way to interpret it is that we don't know at a fundamental level what's going on. Maybe there is an embedding theory that would arise that is simpler, it has fewer input, or maybe just one, and then gives you the values of the standard model and all these theories that know to be exactly the same that we observe in nature. So,
well, just to be clear, if any of us program a computer, a simulation of anything, there's a set of parameters that are established up front, and then you watch what happens thereafter. And then you sometimes tweak the parameters if necessary. Some other parameters are non-tweakable. Almost all of our codes, there's a line that gives the value of pi. That's not tweakable.
We don't have any
sons tell me,
mathematical.
for example, that in Minecraft, when you create a Minecraft world, I'm taught by Philip and Alexander, you have to input a world seed.
Okay.
Yeah, and if you put a different one.
Basically, it means that we don't have the mathematical equations, for example, to say that the mass of the electron should be what we measure and things like that. So we don't have yet a description as why these have these values. So,
but why should we be? This might have to go back to David. Why should we be the measure of what an intellect is, and then judge what is hard or what is easy? So, in other words, just because we think something is hard because of all of these physical constants that come together so that we exist many billions of years after the universe forms, maybe that's just trivial for anybody who's programming the universe.
Yeah, I mean, it probably is trivial. They've probably got sim universe technology. Everyone's running it on their desktop. I mean, someone at Google in the next universe up
universe up. That's not a phrase.
Created sim universe, but it's like, okay, set a few parameters, run the universe, no big deal. Some of those universes produce nobody. Some of those universes produce somebody, and those somebodies have to reverse engineer their universe. And it turns out reverse engineering is really hard, whether you're in a simulation or not. But that's just, if you look at it this way, it's just a matter of perspective.
Because when I think of the game tic-tac-toe, to a child, this is a challenging game. They don't know what move to make next, and then they might win or lose, and then they cheer or they're sad. And then you realize this is a pointless game. You can play so that you'll never lose or win, but then it's no longer fun. But to a child, it is it's a game that challenges them. And then we have the game of chess, which challenges us, but you go up an intelligence level and then it's just a trivial exercise. I don't care how many possible moves there are, it's trivial if their brain is a greater brain than ours. And I'm reminded, which one of you may remember, just to correct me if I don't get it right, was it Feynman who first analogized the laws of nature to our attempt to understand the laws of nature would be like coming upon a game of chess and you know nothing of the game. And you're just watching people move and you don't have the rule book and you have to deduce what the rules are. And so pretty easily you can see, well, this piece moves this way and this only goes diagonal. You get that. But occasionally one of the pieces jumps 2 squares instead of just 1. Well, why did it do that? You make a note of that, right? And then later on, that little piece that jumped 2, it reaches the other end of the board and then it becomes a whole other piece. That's kind of freaky. It's rare, but it happens, and it's an important rule of the game that most of the time you don't see. And so I'm left wondering how much of a chess game without the instruction manual is the very universe in which we live. To get your answers, one each from that. Yes, Zahora.
maybe starting from the philosopher side.
All right, David, you lead off with that.
I would say that's basically the situation we're in. We call that game, this is the game of reverse engineering the universe, and we call it science. A little bit for philosophy too. It's like, hey, there are clues we could get about we certainly get the equations and so on, but hey, there are clues we could get about the grander structure. Hey, maybe at a certain point we're gonna find one of those constants that has an arbitrary value and find there's a coded message in there in the simplest possible language saying, yep, you guessed right, it's a simulation. If so, then that's part of the reverse engineering too, but it's actually a miracle we
Here
have
he goes.
about the world we're in from this perspective. The world could have so much complexity, which is completely beyond us, and it could be that we are simply scratching the surface. But I think to do science, you just got to take the optimistic.
But you left me very disappointed earlier in saying that I was trying to find evidence to show that we're not, and that evidence that we're not could be put in by someone who is.
Yeah, I'm
So
afraid.
that was disturbing. So I'm getting back to Zohora's point. What's the point of thinking that way?
Well, you might take on board Occam's razor, which is if we don't need the hypothesis that we're in a simulation, then we should just do without that hypothesis. Maybe science is going to tell us a bunch of math, it's a bunch of equations. Yeah, that could be combined with the further hypothesis we're in a simulation. It's a lot simpler if we're not. So maybe Occam's razor at least says, why bother? Then on the other hand, you got Bostrom's statistical argument. We might actually produce a whole lot of simulations and have very good reason to believe there are a lot of simulations in the universe, in which case you can just raise the question. We know some people are in simulations. We cannot assign at least probability 0 to us. And at that point, it becomes a statistical question. So I think the standard scientific reasoning of Occam's razor might give some reason to reject it, but the statistics starts to maybe balance that another way. And around a certain point, you got to start doing some math about the probability.
So Occam's razor actually goes very far back, I think, to the 14th century, where was it the Earl of Occam? Was it who suggested
William Occam
that the of all explanations, perhaps the simplest has the best chance of being correct, and that was well before the methods of the scientific method and others. So we've been using it, invoking it ever since. So Lisa, is the universe a chessboard, and we're
So I was very much with you until the very end.
Mm-hmm.
So I think it is indeed true that we don't know the answer, and we're just going to keep doing science till it fails. And it hasn't failed yet. It seems to we make progress, and so we're going to keep doing that. In terms of are we trying to figure it out? I actually love the idea that we're a simulation where they actually kind of saved in efficiency by making us not quite smart enough to figure all of this stuff out. That's too much computational power, so let's make them a little bit dumber. So, but I do have, I understand it's a possibility there's a simulation, but there is a problem with the statistical argument. I think if you asked any statistician, there's just not based on well-defined probabilities here. And actually one of the key, so Bostrom's argument would say that also that you have lots of things simulating things, and lots of things that want to simulate us. And I actually really have a problem with that. And why simulate us? There's so many things to simulate. None of us actually get together and, we simulate processes or whatever, but we mostly.
Why simulate us? There are so many other things to simulate. Like fucking what? You see what I mean? Like what, man? Excuse me, man. There are so many other things to simulate besides life. What exactly? I just need an example of what you would say that just one example of something outside of life that's much more interesting to simulate. I would like to know exactly what the fuck is outside of life. Stupid. Like this lady, yo, man. I don't know, man. I apologize for her being on stage. I don't know how she got this invitation, But this is horrible. And like the glass, like, man, hold on, man. Let me goddamn remove this banner. Look at her. Look at her. Yeah. Like, just look at her. Ain't made sense all night. Been totally wrong and very confident about being wrong. Like almost boasting and just being wrong. Like, this is crazy. Put this damn banner up, man. This lady, man.
Are interested in ourselves. I don't know why this higher species would want to.
Maybe they don't care about us. They just simulate a bunch of physics or a bunch of laws, and hey, we came along as a byproduct.
Yeah, it's in the realm of possibility, but
So we grew out of their petri dish.
But I do think that, again, ultimately, what as physicists, as scientists, we're interested in are the things that we can actually test. So to the extent that it gives us an incentive to ask interesting questions, like, do we see cosmic rays at different energies or from different directions, going at slightly different speeds or anything of that nature, or do we find the laws? I mean, that's certainly worth doing to see what is the extent of the laws of physics as we understand them. But that is what we're doing anyway, but maybe we'll be presented with a bunch of other questions. But that is, I mean, so it's a little bit of a systematic way of figuring out the chess game, because in the case of the chess game, you have many games, you can watch many games. Here we have this one universe, and we can try to make little tests within that universe to try to test laws. But those apply in those little rounds. I mean, one of the brilliant things about Galileo was he realized there's many ways to do science. There's thought experiments, there's observations, but he actually came up with the idea of experiments themselves.
We're bringing him to the next panel.
Yeah, yeah. I know. I'm totally excited about that. You might be that one too. So that's just the nature of science. So I think we are trying to figure it out to the extent we can.
Jim.
I think you nailed it with the chess game analogy. One thing that I think that oftentimes when I talk to people is, and Lisa alluded to this very well, is that a lot of people think it's all about them. They really do. They think it's all about them. They have to understand things that's somehow related to them. It's all about them. And I think that one of the things that science actually teaches us is that it's not all about us. We may be struggling with the description that we're trying to construct, but the universe doesn't care whether I understand or don't understand. The universe doesn't care whether I exist or not exist. The universe, at least as I have studied it, is, I'm going to retreat into Einstein. At the end of the day, it is an extraordinary mystery. That's the sense that I get from having studied science for now 50 years almost. That we live in this place of mystery, and we need to accept a humbleness about our efforts to go out and explain that chess game that you described.
Ooh. Max.
I fully agree with you that
Neil Carter, you said, ooh.
You could be a bit more humble. At the same time, I also feel that the very soul of physics is this audacity to look for a hidden simplicity in things. So I think the metaphor of chess is a beautiful one. We have as a goal in physics to look at this very complicated and messy seeming universe and look for a hidden simplicity, look for rules of chess which are actually simple, not the list of one Googleplex different possible things, or not just saying it's all random. And of course, we don't know yet whether there are rules that are simple enough that our human minds can understand them or not. But I'm an optimist, and I feel it's actually much healthier as scientists if we have this innate optimism. Instead of saying, well, it might be they were too dumb to ever figure this out, so let's just not try. I think it's much healthier to say there is a real possibility that there is this hidden simplicity. And in fact, Galileo and Einstein and so many before us have found simplicity far beyond what their ancestors ever dreamt of, right? So let's keep looking for even more hidden simplicity. Maybe this is actually all computational or mathematical, which will be, that's in a way the ultimate audacity to hope for that, because that would mean that in principle, at least, it really is possible to figure out the rules of the game. That's the attitude I like to take. Consider the possibility it is possible, and then try our very, very best to actually figure it out.
Thank you, Mario, for that. And Morpheus. So, Zohore.
I would like to deviate a little bit more from your question very quickly, because it didn't come up in the discussions, but I want to distinguish between the idea that we can simulate the universe as opposed to the universe being a simulation, because there are fundamental limits to our capability to actually compute things, and these are based on the physical laws that govern our universe. Basically, we can't have infinite power. The energy, the laws that govern basically the uncertainty principle can limit the rate that we can process logical operations, and also the entropy and thermodynamic laws can limit the amount of memory that we can hold in a given amount of space-time, and things, ideas like this that were discussed by Steph Lloyd and other people. And therefore, we might not be able to actually, and there are other actually limits when you think about larger scale and expansion of the universe, whether or not you can ever causally connect to parts of the universe that is expanding, and therefore store and process those information, be able to actually re-simulate the universe that we have. So it's a different idea. I don't think that based on the physical laws of our nature, this could be possible, but that doesn't mean that our universe could not be a simulation inside another universe that has another laws of physics that doesn't actually limit the amount of computation that is required to simulate the universe. So these are two different ideas. Just to come back to your question, I think as a physicist, thinking about the simulation idea, I think it doesn't change the way I think about the science, and I do my everyday job as a scientist. I think just the notion of whether or not we're real or just simulated, it's kind of irrelevant, because what we're observing is no different from being real or imaginary. We just go and discover things that we already don't know about the universe, the laws that we haven't discovered, but at some point maybe we find some sort of more strong evidence that could connect us to a higher level that says something about whether or not the universe is computational based, and there is something, some simulator beside us. These are the ideas that require more thinking and more thinking out of the box, I would say, at the moment, but maybe at some point in future, when we have more understanding of the laws of our universe, we can have more rigorous way to go and look for those evidences and say something meaningful. At this point, I think there is no such evidence. We've just started to make assumptions by just comparing our simulations of the universe and see what would be the consequences of those kind of assumptions. But at the moment, we don't have such evidence, and it would be wrong to put a lot of focus on this idea, but it's definitely a very fun and curious idea to think about as a scientist, and therefore I think that's why I do science. And
I just have to alert you that she actually knows the answer to your chess question, and she's just not telling us, because you're Persian, and you Persians invented chess.
Yeah, I actually played that game when I was very, very young. So it's.
So she does have the answer. Let me just end before we transition to Q&A. I want to get the likelihood that you think we are in a simulation. 10% chance, 20%. What? Just give me a number. Just a number. Go.
I can't give you that number. I don't have any evidence.
She's not authorized to divulge that information. Okay, so you give a no answer. Max?
17%.
17%. Jim? Morpheus?
1%.
1% chance.
I'm going with effectively zero.
Effectively zero. David?
42%.
I think the likelihood may be very high. And my evidence for it is just, it's a thought experiment, and it's simple. We'll just end with this reflection. And I'm elsewhere, like on YouTube, saying this, so you can check it out again later if you choose. I just think when I look at what we measure to be our own intelligence, and we tend to think highly of it. Getting back to Jim's point, there's a certain hubris just even in how we think about our relationship to the world. And it's understandable, perhaps, even in the search for intelligent life in the universe. It comes with the assumption that we will find life that also thinks we are intelligent. Well, if we look at other life forms on Earth with whom we have DNA in common, there is none that we would rank ever in the history of the fossil record or life thriving today that we would rank with us and our level of intelligence. So given our definitions, we're the only intelligent species there ever was, because we have poetry and philosophy and music and art. And then I thought to myself, well, if the chimpanzee has 98 whatever % identical DNA to us, pick any animal, doesn't matter, dogs, doesn't matter. Mammals have very close DNA to us. They cannot do trigonometry. Some people can't do trigonometry, certainly not these animals. So if they cannot do trigonometry and they have such close genetic identity to us, let's take that same gap and put it beyond us and find some life form that is that much beyond us that we are beyond the dog or the chimp. What would we look like to them? We would be drooling, blithering idiots in their presence. The smartest chimp can do maybe some sign language and stack boxes and reach a banana, put up an umbrella, like our toddlers can do. Our toddlers do that. So maybe the smartest human, you can bring Stephen Hawking forward in front of this other species, and they're chuckling because they'll say, oh, this happens to be the smartest human, because he's slightly smarter than the rest because he can do astrophysics calculations in his head, like little Timmy over here. Oh, you're back from preschool. Oh, you just composed a symphony. That's so beautiful. Just put it on the refrigerator door. Or you just derived all the principles of math. Oh, that's cute. And so that is not a stretch to think about. And if that's the case, it is easy for me to imagine that everything in our lives is just the creation of some other entity for their entertainment. It is easy for me to think that. So whatever the likelihood is, 0%, 1%, 1742, no answer. I'm saying the day we learn that it is true, I will be the only one in the room saying, I'm not surprised. Thank you all for coming tonight, and thank the panel. We will bring up the lights, and in this transition between the formal part of the panel and the Q&A that we'll be taking from you, I just want to tell you just what it takes to run this thing. As I told you earlier, it was formed by an endowment created by Isaac Asimov's widow, Janet Asimov, and friends of Isaac Asimov. And we've been going strong ever since. And so I just want to say we have people who run this thing. We have Susan Morris, who's director of Hayden Programs. Where's Susan? Susan is out there. And we have Emily Haydet. She's also part of this team that makes this work. We have my executive assistant, Elizabeth Stachow. We have Laura Jean Checky, who's our stage manager. We have some fans of Laura in the audience. Good. We have Miriam Posner, who has been with us like forever and is a diehard supporter as a volunteer of our programs. Lydia Marie Petrosino. Did I pronounce that right? Lydia, I only ever call you Lydia Marie, but Lydia Marie is good. And of course, we have Betty Walrand. These are people who make this happen every single year. I just want to collectively give them applause. We have about 15 minutes for Q&A, so let's go straight to it. We'll go back and forth, left and right. No one will hear you unless you speak into the microphone. So let's start here. Let's go.
Okay, so my question is, does it really matter? Would you view the universe differently if we knew it was simulated? Could we do the math differently?
Oh, I like that. To make this efficient, we'll pick one person to answer. So how about Max, because your book is titled, what's the title of your book?
Our Mathematical Universe.
Yeah, so he's the guy to answer this question, okay? If you knew, would your math be different?
Well, I'll take your question to mean if I knew, would that make me super depressed or super excited? Would it change the way I feel about everyday life? My answer is absolutely not. I feel that when we look at these rather sterile equations or the computer code or whatever it is that's running this, there's no meaning or purpose built into that. We shouldn't look to our universe creating the meaning for us. It's we who give meaning to our universe. So the way we feel about things and the meaning we create is the same, regardless of whether we're simulated or not. And I think this is very much the point that David was making earlier also. We shouldn't diss things just because you're simulated.
The math is a little bit different if we're simulated, on the other hand, because there's also the math of the simulating universe.
Right.
There's a math of our universe embedded in a bigger one, which raises some exciting prospects. It's like, hey, maybe we could get out and explore that one. So that'll be cool.
Wait, so you're saying, can you embed a complete system of mathematics within a higher system of mathematics?
Yeah, maybe the embedding universe is a vastly higher level of complexity than ours in order to have the computational power, for example, to simulate ours. And hey, maybe they'll let us out one day. We're just computers in their world. They'll give us input devices.
So you feel like you're in prison?
No, it's just like, it's like Earth is cool, but the galaxy is even cooler.
Okay. Yeah, a quick one here.
I think it would feel different. It's like, it always interests me that if you miss a basketball game and you know it already happened, it's less interesting to you to watch, even though you know it happened already, and because it's not happening in real time. And you might not even know the result, but I think there is a sense in which psychologically, the idea that it is pre-programmed would be disturbing, at least to me.
My analogy to that is if you go to the Smithsonian Air and Space Museum in Washington, and you see the Apollo 11 command module that went to the moon and came back, and there it is. If you made an exact replica of that and put it on display anywhere else and say, you cannot really tell the difference except microscopically, but it's a fake, it means it's different to you, even though you can't tell the difference. The knowledge that is real seems to matter to us than if it's a simulation or a model. In that case, so I have to agree. I reluctantly agree. Well, I don't want to agree, but I have to agree.
I disagree for one reason. I don't do science to make me feel something. I do science because I think it's an investment in the long-term survival of our species. Our science underlies our technology. If our environment changes, we will use that technology to survive. Well, that's true whether we're simulations or not. That's why I do science.
Are you also running for president?
No, because they can't talk about science.
By the way, Jim Gates is on the President's Committee of Advisors of Science and Technology, PCAST, and you've been there for almost the entire administration. So keep up the good advice that you're giving. Let's go right here. Hey, how you doing?
Good.
What grade are you in?
8th grade.
8th grade, cool. So what do you have?
So you were saying about bugs in the code of the universe if it is a simulation. How come if it probably statistically would not be perfect, how come we have not so far seen any like corruption or glitches maybe in the far looking like the cosmic background radiation? How have we not seen anything that just seems like it couldn't be there?
That's
great question. Jim, what do you got?
That's an easy one to answer. Up until September of last year, we had never seen gravity waves either. The point is that our technology was not sufficient and might not be sufficient now.
Okay, so.
Hey, he an asshole.
So
if you see how he looked at the kid, he looked off. He an asshole. But he treated the kid like a scientist. But his facial expression was assholes.
May still be there, just haven't found it yet. That's a cop-out answer, I think, between you and me, but don't tell him that I said that.
No, maybe I.
Oh, wait, yeah, sorry, yes.
Yeah, so exactly, the line of investigation that we had in our paper is whether or not the simulation is imperfect, as you say. So given that we haven't already seen something doesn't mean that we might not see something. And therefore, as I said, we look for evidences that tells us that there are some imperfection in the universe because the simulator or the amount of computation that could be done to generate our universe has been finite. It hasn't been infinite, and therefore there might be some evidence. But it doesn't mean that the fact that we haven't seen it doesn't mean that we shouldn't go and look for it. It's been difficult, but.
But I thought the question was, why haven't we seen it? That's what I answered.
Well, yeah, and don't you both agree? You're saying if you haven't seen it, doesn't mean it's not there, and keep looking.
Right.
Good. I've got a question from Twitter that came in. Evan Quinter from the Twitterverse asked, I think I'll direct this to Max. If the universe is a simulation, does that mean there's a limit to how far our universe can reach? Because we speak of an infinite universe beyond our horizon all the time. So you're ready to say if it's a simulation, it can't be infinite, and there is the limit to the code.
It's a great question. If we are being simulated in one universe up on finite computational resources, yeah, then either the size of our universe is actually finite, or there's some other trick, like it just keeps repeating itself over and over again.
Like the background in the Flintstones when they're riding in the car.
Precisely.
The background just repeats.
An optical illusion.
I said, you can't draw me. What's with your budget? Ever see the backdrop of cartoons when people are running? It just repeats. When I was a kid, that disturbed me.
Maybe it's a just-in-time simulation. It's kind of like the Truman Show or something. You know, they started off simulating me in Australia, where I was born. And one point up, I came to New York, so suddenly they had to like simulate all of you guys and
for you.
Yeah, exactly. Or for whoever. Or maybe they started
what I'm
with the
saying?
Earth. We go to
This guy.
Voyager just reached, the thing just reached Pluto, so now I had to simulate Pluto.
And then he looks fucking high, yo. Like, I'm just gonna be real. Like, I don't know why this guy is here. Every joke, none of his jokes have hit. Not one. We ain't, like, not one joke is hit. They've all just fallen short of the glory. And he keeps trying it. And then the worst part is, it's like, bro, you're stuttering through the fucking sorry ass jokes that you're trying to tell. Can you stop? Can you please stop and just answer the question, bro, like a normal person? I hate people who play all the fucking time. Like, that shit is aggravating as fuck. Every time we ask you a question, bro, it don't need a joke to go along with it, my nigga. Just answer the question. Damn. Like, and then it's bad jokes. You're not fucking funny, bro.
Voyager just reached, the thing just reached Pluto, so now I had to simulate Pluto.
I see.
It's like that. So it's, stop.
Nobody sees.
Stop small, go bigger.
Yeah, don't get me started on Pluto, first of all. But what you're saying is they might be just laying down the bricks in the road as we drive along.
Just-in-time simulation, they call it.
Just in time.
Yeah, simulate only as much as you need.
Okay, right here, yes.
Hi. So we briefly discussed infinity and how it relates to this topic, but I was just wondering on the other end of the spectrum, why is nothing not a thing? Why is there not nothing when you come down to the fundamental question?
But we had an entire Asimov panel on that very subject. Where were you? The title of that was called The Existence of Nothing. And we had all the experts on nothing.
We on that one
on the
next.
stage at the time. I'm just saying. So, okay, maybe he didn't know that. So,
I actually have a probabilistic argument.
okay, so we'll entertain it, but go online. The whole thing is there. It's called The Existence of Nothing. Okay, yes.
So in my book, Dark Around the Dinosaurs, I have a section on cosmology, and I actually talk about the probability of nothing. And I think nothing is just very unlikely. I mean, first of all, we wouldn't talk about nothing because we wouldn't be here. But nothing is just one point. If you think of a number line, 0 is just 1 point on it. And nothing is just, I would say it's very unlikely. And if you have an explanation of why there's nothing, then there's something there that allowed you to have the rules that explain it.
So you're saying the act of posing the question of why there's something is proof that there could not have been nothing?
Right. So
Nothing is asymmetry.
Crystal clear. Now,
that's one answer, and the other answer is probabilistic.
Okay, yes, sir.
Hi, Neil. How are you?
Hi, good.
So I think I'm going to say
A
this.
perfect symmetry.
I'm going to say computer and program when I wake up in the morning. But the question is, say we assume that we are in a simulation. We don't try to prove it anymore.
We come out of perfect symmetry into asymmetry
to predict what inputs might be
to go back into perfect symmetry.
This is an original idea, and it's not an input from the programmer. And we're not, on a holodeck within a holodeck within a holodeck. Can we? You think that would be possible and maybe escape the simulation?
David, what do you have?
Well, I think we're probably stuck for now with
Why did they ask him?
of the actual simulation of the simulated universe. If it's a perfect simulation, we're not going to be able to do better than that. We're not going to get information about the character of the simulating universe. Now, if it's a buggy simulation or if it's interactive simulation, if they're sending messages down here in the way that God was supposed to, and so on, then all bets are off. All I can say is so far, I've not seen evidence that we could use to make predictions. Hey, well, tomorrow the simulators are going to, call the whole thing off. So all we can do there is speculate, as far as I can tell. If Zore's work pans out, maybe we'll suddenly have a lot more evidence.
And I want to add that at the end of the day, we are living in this universe. So we are constrained by the laws of this universe. So the concept of escaping from this universe doesn't seem logical to me, because we are bound to be evolving according to the laws of this universe and not something beyond that.
Plus, if other universes have slightly different laws of physics, I don't want to be the first to visit them. Send something else, then we'll figure it out. We only have time for a couple more questions, one of which I'm going to take from our Twitter list. But let's go right here, sir. Yes.
Sorry, no, I tend to disagree with your conclusion about the universe simulation percentage, and more agree with Lisa's 0%. Here's why. Using your chessboard analogy, yes, there are 64 pieces on a chessboard. You can assign numbers to each piece.
There's 64 squares.
64 squares,
Yeah.
right. And you can assign values, numerical values to the chess pieces, and then use computers to see into the number of plies, 3, 4, 5, and then run the simulation, and you get the end result, see who's going to win, and so forth. However, just look at, the humans on this earth. We have 7 billion people now on earth, and even we can mathematically model one person. When we have interactions of each other, we have interactions of more than each other, because every action there's a reaction, and then we have 7 billion people. So the result is going to be totally unpredictable. In fact, it doesn't look too good, because the Earth with its limited resources and the Earth population growing at a logarithmic rate. It's
exponential
conclusion,
rate. Yeah.
Exponential, right?
Yeah.
It's going to be one conclusion, and that is, the result is not going to be good. So,
but it may be that these multiple interactions that transcend our native ability to compute are no different from the tic-tac-toe game being played by the 5-year-old. We're just too stupid to know.
Well, that's true.
Okay. That's right.
But again, when you look at the complexity and try to mathematically model 7 billion people's characteristics.
Yeah, we can't do it because we just have human
Absolutely.
brains.
Thank you very much.
Yeah, bro, like he thought he was coming off smart. I disagree with your chess analogy, and then goes breaking down chess. Nigga, the point of the chess analogy was the level of understanding. You can't go into the chess analogy without first starting with his first analogy, which was tic-tac-toe to a child. And then chess being challenging to us. And then at some point, when you become a chess player, you can see the whole board and it looks different to you, as opposed to how it looked when you were just sitting next to it without the fucking rule book. This is no different. Like, I don't know where these smart dumb people be coming from, yo. Like they don't hear themselves.
Yeah, sure. Forgive the rest of the people online. The last question is going to have to be from our Twitter stream here. And this one I'm going to send to Lisa. Lisa, you will take us out with your answer to this question. This is from Ashley Canino. Is dark matter, there are multiple ways you could probably get to this, but let me say it as it's written. Is dark matter transparent or simply rules of the game, a computational structure like an operating system? And think of dark matter and dark energy, these permeating elements of the universe that we don't understand at all. We don't know what's causing them, but we can measure their existence. Could that be the blood of the operating system throughout the universe?
So it's an interesting question, and people have asked that question. And you have to take a little bit of an Occam's razor approach here. So first of all, dark matter is indeed transparent matter. It's matter that light just goes through. There's evidence for it, not because we see it, because it doesn't emit or absorb light, but because it has gravitational influence, and we can observe the gravitational influence. Now you can ask, is that because we got the laws of physics wrong and there really wasn't matter and we got the laws of physics wrong? Now, first of all, it's a lot simpler to believe this matter that we have no reason to believe shouldn't be there is there than to think we got the laws of physics wrong. Because the laws of physics work incredibly well over many distant scales. So there's no evidence that those laws of physics are wrong. But furthermore, there's more and more evidence that makes it look just like it's matter. One of the things is known as the bullet cluster or other clusters, which are really mergers of clusters of galaxies. Clusters of galaxies are bound states of many galaxies head together. And when those things go through each other, a cluster of galaxies has gas in it, it has stars, and it has dark matter. When it goes through it, you see the gas gets stuck in the middle. You can see that through X-rays. Through gravitational lensing, you can see the dark matter just pass through. It acts just like you would expect matter that's not interacting to act. It goes right through, the gas stays in the middle. Now you can try to mock up equations or some simulation or something that does that, but it looks just like matter would look. It's exactly what you would predict.
Except we established earlier that we don't form our own galaxies without the existence of dark matter creating the womb in which we collect. So isn't that kind of like an operating system, enabling matter to do its thing?
Well, gravity is, in some sense, the operating system, but gravity is responding to the existence of the dark matter. And dark matter does play a big role. There's more of it. It collapses. It doesn't interact with light, so it can form structures more easily than normal matter.
I like that. Gravity is the operating system. Well, how about dark energy?
Dark energy is another just thing that's in there that's responding to gravity. So dark energy is, for those of you who don't know, it's smoothly distributed. It's not like matter that clumps together.
It's the operating system.
It's not the operating system either.
The operating system is everywhere you touch on a computer. So is dark energy.
I'm just getting confused now. It's part of what I put in, at least in my initial state, and then I let the gravity equations work on it. So
you was confused the moment you got there.
And then you can ask, what is the effect of this energy that we don't observe directly? In some sense, we observe the fact that it is responsible for the acceleration of the expansion of the universe. But gravity is the only law there. The other stuff is just stuff. Dark energy is stuff. Dark matter is stuff. The gravitational equations are acting on that, and it's actually creating the gravitational force.
Well, so if gravity is the operating system of the universe, I can't wait for Universe 2.0. Thank you all for coming this evening. And thank the panel.
Makes no sense. If gravity is what was expanded in the universe, it should be slowing down, not accelerating. Unless you're saying gravity is a force that's pulling from outside of the universe. It's the only way gravity would be expanded in the universe. It would have to be outside of the universe, pulling it at an accelerating speed. But if it was something that's an emergent property of the universe, then gravity should be slowing the universe's spread down. But I think we got the gist of this. I think it was definitely an excellent discussion. we gonna definitely continue to go further into it. The next one that we gonna do, we gonna look at, we gonna go a little bit deeper into the universe and how how messenger particles work. And just because I wanna show the connection between cosmology and biology, right? Because like we hear the principle of Tahuti on the regular, which is, you know, what they say, as so above, so below, as so within, so without. I want to actually show you the truth to that, right? So what you'll see is the same way that chromosomes are copied, you'll see the same way particles are also copied and created in the universe, right? We'll get into that. It follows the same structure, right? We start getting into messenger particles. They play the same role as RNA, right? Decoding and then translating the code given. So, like I said, man, we definitely we got a long list of things to go down, but the key is getting just us having the basic understanding that we are more than our bodies, right? We use a body. We are not the body, right? This is no more than a vessel used to interact with the simulation. No more, no less. No more, no less. We don't have the emotional discussions about whether things are perfect and the programmer did it perfect and did he make mistakes and all of that. We're not here for that. We're not here for that, right? Because at the end of the day, we are the programmer, right? And that's really the key to what we really gonna get into, is that when we are in our true form, we are the programmer. We are the ones that created the simulation, right? So not only will you not be able to see God in this flesh, but you won't be able to see self in this flesh. The only way to see your true self or to interact with your true self or your higher self is the moment that the flesh decays and you begin to transition into the next phase or the next part of the cycle. So, like at the end of the day, you're more than what meets the eye, right? You're more than what meets the eye. And we don't have no trouble over here proving it, right? Yeah, we beat up the dogma, but don't think that this is atheism over here. Not by a long shot. What we are doing is showing you is that there is a program of the universe, and you can actually make the logical and a very logical argument and a very solid argument for there being a programmer without being allowed to be manipulated by the emotional conversation of the dogmatic God, right? That's what we're trying to avoid. With that being said, I appreciate y'all, man. Power to the dark side. Nobody is able to put it together like the dark side. Nobody. Nobody, period. Y'all just not gonna get it like this. You know what I mean? So shout out, you know, to what we do. This is definitely what we call dark energy. You know what I mean? This definitely came from you know, antimatter, from the realm of antimatter. You know, this knowledge is definitely, like I said, antimatter and matter coming together, exploding, right, and creating what we have now. So I appreciate everybody though, man. We're gonna run it back. I'm gonna cut it here. Peace.
it's moving through.
Dark side, dark side.
Clearing up all the lies and the rumors too.
Dark side, dark side.
You say you want my life, you gotta fight me first.
Dark side, dark side.
Come outside round here, there's nothing like church.
Dark side, dark side.
Come and get this life work.
They talked about Jesus, give them something to Babylon. Just know my whole team is battle tested and battle strong. One world speaking that Tower Babel tongue. Cole Hammurabi thinking ancient Babylon. No pun intended, Reaganomics had us under avalanche. We took off like a rocket, they was praying we could never launch into the upper echelon. You can never be yourself. Every day is Comic-Con, fast money Ramadan. Who collected Comic-Con? Cold check my vital signs. Motel 6 float. Woke up with the brightest mind. Out of sight, out an idle mind. They hate it when you idolize. We living in the final times. Guess you Ellen Keller blind.
Spirit when it's moving through.
Dark side, dark side.
Clearing up all the lies and the rumors too.
Dark side, dark side.
You say you want my life, you gotta fight me first.
Dark side, dark side.
Come outside round here, there's nothing like church.
Dark side, dark side.
Come and get this life work.
Put my soul on the altar, I never offer a sacrifice. The blood that we need for the lamb ain't never acting right. I take my path tonight, knowing that I might have to fight. I probably grab a knife and a 9. I guess I'm packing light, focus on the now. Just as much as the afterlife, I recognize the spirit is only taking up half the fight. Stairway to heaven, he won't make it up half a flight. He working, making bacon bits, probably out on the Sabbath night. Shoot for the moon, hoping to hit a satellite. You can ask them why when they see me, they call on Adonai. When we both know at the most he telling you half a lie. Feel the transition begin to happen when passing time. I came back in the sky, just like an astronaut, to say you selling Africans out. See you and asking Mike, and it's sad to say they really had it bad for Christ. And I hear the Habasha thinking they are the half as
The
white.
spirit when it's moving through.
Dark side, dark side.
Clearing up all the lies and the rumors too.
Dark side, dark side.
You say you want my life, you gotta fight me first.
Dark side, dark side.
Come outside round here, there's nothing like church.
Dark side, dark side.
Come and get this life work.